Hello and a warm welcome to the Sleepy Facts channel, a place where curiosity meets calm and the wonders of our world unfold gently, one fact at a time. Tonight, we invite you to settle in, relax, and join us on a serene journey across the incredible planet we call home. In this video, we will explore 150 fascinating truths about Earth, from the secrets of its fiery, sun-hot core to the silent, drifting continents on its surface. We'll dive into the vast, hidden oceans within its mantle, understand the magnetic shield that protects us, and marvel at the extremes of its deserts and frozen poles. We'll uncover why the sky is blue, how the deepest ocean trenches host life, and what causes the majestic dance of the auroras. Each fact is a small piece of the grand puzzle that is our planet, a story 4.5 billion years in the making. So, get comfortable, let your mind wander, and prepare to see Earth in a whole new light. Here are 150 facts about our amazing world. Fact 1. Earth is not a perfect sphere. We often picture Earth as a perfect blue marble, but this is a slight oversimplification. Its true shape is an oblate spheroid, meaning it is squashed at the poles and bulges at the equator. This distinctive form is a direct result of its rotation. As our planet spins on its axis, centrifugal force causes the material at the equator to be pushed outward, much like a pizza chef spinning dough. This creates a measurable difference in Earth's diameter. The equatorial diameter is about 12,714 kilometers, while the polar diameter is roughly 12,714 kilometers, resulting in a difference of over 42 kilometers. This bulge means that point on the equator is actually farther from the planet's center than any point at the poles. This shape has significant implications, affecting everything from the planet's gravitational field, which is slightly stronger at the poles than at the equator, to the orbits of satellites. GPS systems must account for this geoidal shape to provide pinpoint accuracy, as the gravitational variations can subtly alter satellite trajectories. So, while it appears round to the naked eye, Earth is more accurately a slightly flattened, slightly lumpy sphere, a shape perfectly sculpted by the forces of its own motion. Fact 2. The Earth's core is as hot as the sun. Beneath the familiar crust and the vast mantle lies Earth's engine room, a core with temperatures rivaling the surface of the sun. Scientific estimates, primarily based on seismic data and experiments with materials under extreme pressure, place the temperature of the solid inner core at a staggering 5,700 degrees Celsius, 10,300 degrees Fahrenheit. This is indeed comparable to the sun's photosphere. This immense heat originates from two primary sources: the residual energy from the planet's violent formation over 4.5 billion years ago, when cosmic collisions generated incredible thermal energy, and the ongoing decay of radioactive isotopes like potassium-40, uranium-238, and thorium-232 within the core. This heat is not just a geological curiosity, it is the fundamental driver of our planet's dynamics. The tremendous thermal energy creates convection currents in the outer core's liquid iron, which in turn generate Earth's magnetic field through a process called the geodynamo. This magnetic field is our planet's invisible shield, deflecting the solar wind, a constant stream of charged particles from the sun, and protecting our atmosphere from being stripped away, thus making life on the surface possible. Fact 3. Earth has a solid inner core. At the very heart of our planet, under pressures more than 3 million times greater than at the surface, lies a remarkable paradox: a solid ball of iron-nickel alloy, known as the inner core. Despite temperatures that exceed the surface of the sun, the material here cannot melt. It is forced into a solid state by the unimaginable compressive force exerted by all the layers above it. Scientists believe it is primarily composed of iron, with a small percentage of nickel and possibly some lighter elements like oxygen, sulfur, and silicon. The inner core is roughly 1,200 kilometers in radius, about the size of Pluto, and it spins slightly faster than the rest of the planet. This superrotation is a key component of the geodynamo that creates our magnetic field. It is thought to have begun crystallizing from the molten outer core around 1 billion years ago, and it continues to grow very slowly as the Earth gradually cools from the inside out. This growth releases latent heat and light elements, which buoyantly rise into the outer core, further fueling the convection currents that are essential for sustaining the magnetic field that protects all life on Earth. Fact 4. Earth's outer core creates its magnetic field. Earth's magnetic field, our planet's invisible defensive shield, is generated by a colossal natural engine deep within its interior, the liquid outer core. This 2,300 kilometer thick layer is composed primarily of molten iron and nickel, swirling in complex patterns. The process that creates the magnetic field is called the geodynamo. It begins with heat from the solid inner core, which causes the liquid metal in the outer core to rise in massive convection currents. As the hot metal rises, it cools and sinks again. Combined with the Coriolis effect caused by Earth's rotation, these currents are twisted into spiraling vortices. The movement of this highly conductive, molten metal generates powerful electrical currents, and according to the principles of electromagnetism, these electric currents, in turn, produce a magnetic field. This self-sustaining cycle creates a vast magnetic bubble around our planet, known as the magnetosphere. This field is crucial for life as we know it. It deflects the continuous and dangerous stream of charged particles from the solar wind, preventing it from eroding our atmosphere and shielding the surface from harmful radiation. Without this dynamic, churning liquid core, Earth would be a barren, irradiated world. Fact 5. The mantle is Earth's thickest layer. Sandwiched between the thin crust and the metallic core lies the mantle, Earth's most substantial layer, comprising a staggering 84% of the planet's total volume. This rocky shell extends to a depth of approximately 2,900 kilometers and is composed of silicate minerals rich in iron and magnesium. Despite being solid, the mantle behaves in a ductile manner over geological timescales, flowing incredibly slowly in a process called solid-state convection. This movement is driven by heat from the core. Hotter material from the deep mantle rises in plumes, while cooler, denser material near the crust sinks. This relentless, sluggish circulation is the primary engine driving plate tectonics. The rigid tectonic plates that form Earth's surface are essentially riding on top of these convective currents. The mantle is divided into the upper and lower mantle, with a transition zone in between where mineral structures change under increasing pressure. While the mantle is solid, localized regions can melt, particularly where pressure is released at mid-ocean ridges or where water is introduced at subduction zones. This melting generates the magma that fuels volcanoes and creates new oceanic crust, continuously reshaping the face of our dynamic planet. Fact 6. Earth's crust is thinner than an apple's skin. The Earth's crust, the rigid outer shell upon which all life exists, is remarkably thin when considered on a planetary scale. A powerful analogy is that the crust is proportionally thinner than the skin of an apple. This layer represents less than 1% of Earth's total volume. It exists in two primary forms, the continental crust and the oceanic crust. The continental crust, which forms the continents and their shelves, is thicker, ranging from 30 to 70 kilometers, and is composed of less dense, granitic rocks. In contrast, the oceanic crust, which forms the ocean floors, is much thinner, typically only 5 to 10 kilometers thick, and is composed of denser basaltic rocks. This difference in density is fundamental to plate tectonics. The denser oceanic crust sinks beneath the lighter continental crust in subduction zones. The crust is not a continuous shell but is broken into a mosaic of tectonic plates that float on the ductile upper mantle. The extreme thinness of this layer highlights the fragility of our habitable environment and underscores how the immense geological forces that shape our planet operate just beneath our feet. Fact 7. Continents are constantly moving. The continents we see on the world map are not fixed in place. They are passengers on gigantic slabs of Earth's crust called tectonic plates, which are in constant, albeit slow, motion. This process, known as continental drift or plate tectonics, moves continents at about the same speed your fingernails grow, a few centimeters per year. This movement is powered by the relentless heat-driven convection currents in the mantle below. Where plates pull apart, as at the mid-Atlantic ridge, new crust is formed from upwelling magma. Where they collide, one plate may be forced under another in a subduction zone, creating deep ocean trenches and volcanic mountain ranges like the Andes. When two continental plates crash, they crumple and fold, forming massive mountain belts such as the Himalayas. This perpetual dance has repeatedly assembled and broken apart supercontinents throughout Earth's history, from Rodinia to the famous Pangaea. This motion is responsible for shaping Earth's surface, redistributing landmasses, influencing ocean currents and climate patterns, and creating the geological environments that concentrate the resources upon which modern civilization depends. Fact 8. Earth has a powerful magnetic field. Encasing our planet is an immense, dynamic force field known as the magnetosphere, generated by the churning of molten iron in Earth's outer core. This magnetic field extends tens of thousands of kilometers into space, creating a protective bubble that interacts with the solar wind. Its shape is not symmetrical. It is compressed on the side facing the sun and stretched into a long magnetotail on the night side. The field has a north and south magnetic pole, which are close to, but not exactly at, the geographic poles. Its most critical role is acting as a shield. The solar wind, a constant stream of charged particles from the sun, would otherwise gradually strip away our atmosphere, particularly the light gases essential for life, much as it is believed to have happened on Mars. Instead, the magnetosphere deflects most of these particles, channeling some toward the poles where they interact with the atmosphere to create the beautiful auroras. This invisible barrier is therefore not just a scientific curiosity. It is a fundamental prerequisite for a stable atmosphere and the continued existence of life on Earth's surface. Fact 9. The magnetic poles can flip. Earth's magnetic field is not permanent or stable. Throughout our planet's history, the north and south magnetic poles have swapped places in events known as geomagnetic reversals. Evidence for these flips is permanently recorded in the volcanic rocks of the ocean floor. As magma erupts at mid-ocean ridges and cools, iron-rich minerals within it align with the prevailing magnetic field, creating a continuous magnetic tape recording as the seafloor spreads. Analysis of this record reveals that reversals are irregular, occurring every few 100,000 years on average, though with no set pattern. The last full reversal, the Brunches-Matuyama reversal, happened about 780,000 years ago. Fact 10. Earth's gravity is not the same everywhere. The force of gravity on Earth is not a uniform constant. It varies slightly from place to place across the globe. These variations are due to several factors. First, because Earth is an oblate spheroid, points at the equator are farther from the planet's center of mass than points at the poles, resulting in slightly weaker gravity at the equator. Second, variations in topography and geology play a significant role. A massive mountain range like the Himalayas adds extra mass, which increases the gravitational pull very slightly. Conversely, deep ocean trenches have less mass and thus slightly weaker gravity. Furthermore, differences in the density of the rock beneath the surface, such as dense mantle upwellings or less dense sedimentary basins, create local gravitational anomalies. Scientists map these subtle differences using dedicated satellites like GRACE and GOES, which measure the lumps and bumps in Earth's gravity field with extreme precision. These geoid maps are crucial for understanding ocean circulation, as sea level follows these gravitational contours, and for calibrating the precise altitudes of satellites and their instruments. Fact 11. The planet is mostly iron, oxygen, and silicon. If you could separate Earth into a pile of its constituent elements, the composition would be dominated by a few key players. Iron is the most abundant element by mass, making up about 32% of the planet's total. This is because the vast majority of it is concentrated in the core. Oxygen comes in second at about 30%, and silicon is third at around 15%. These three elements together form the bulk of our planet's mass. The prevalence of oxygen might be surprising, but it is a major component of the silicate minerals that make up the mantle and the crust, and of course, it is a key part of the water molecule in the hydrosphere. The remaining percentage is a mix of magnesium, sulfur, nickel, calcium, and aluminum, along with trace amounts of all other elements. This elemental distribution is not uniform throughout the planet's layers. The core is an iron-nickel alloy, the mantle is rich in silicon, oxygen, iron, and magnesium, and the crust is primarily composed of silicate rocks. This specific chemical recipe is fundamental to Earth's geology, its magnetic field, and its ability to support life as we know it. Fact 12. There is a vast ocean inside the Earth. The greatest reservoir of water on Earth may not be on its surface, but hidden deep within its mantle. Scientific evidence suggests that a vast amount of water is locked up in the rock of the transition zone between the upper and lower mantle, between 410 and 660 kilometers deep. This water is not in the form of liquid lakes or oceans, but is stored within the crystalline structure of minerals like ringwoodite. Studies indicate that this mineral can act as a sponge, holding water in the form of hydroxide ions. The volume of this subterranean reservoir is staggering, Some estimates suggest it could contain as much water as all the world's oceans combined, or even more. This hidden ocean plays a crucial role in planetary geology. It influences the viscosity and melting point of the mantle rock, facilitating the convection currents that drive plate tectonics. It also acts as the planet's deep water cycle, with water being subducted down with tectonic plates and potentially being released back to the surface through volcanic activity over millions of years. Fact 13. Earth's atmosphere reaches far into space. Earth's atmosphere does not have a sharp boundary. It gradually thins out with altitude until it merges with the vacuum of space. However, for practical purposes, the Kármán line at 100 kilometers above sea level is often used as the boundary between atmosphere and space. The atmosphere is composed of distinct layers, each with unique characteristics. The troposphere, where we live and where weather occurs, extends up to about 12 kilometers. Above it, the stratosphere contains the protective ozone layer. Further out, the mesosphere, thermosphere, and exosphere stretch for hundreds of kilometers. The International Space Station orbits within the thermosphere, where the atmosphere is so thin that individual gas molecules are kilometers apart, yet it is still substantial enough to create slight drag on satellites. The outermost layer, the exosphere, can extend to nearly 10,000 kilometers, where hydrogen and helium atoms can escape into interplanetary space. This immense, layered blanket is essential for life, providing air to breathe, shielding us from meteoroids and harmful solar radiation, and trapping just enough heat to maintain a stable climate. Fact 14. The ozone layer protects us from UV radiation. Located within the stratosphere, roughly 15 to 35 kilometers above the Earth's surface, lies the ozone layer, a region with a higher concentration of ozone molecules. These molecules, each composed of 3 oxygen atoms, are crucial for life on land. They act as a planetary sunscreen by absorbing the majority of the sun's harmful ultraviolet radiation, specifically the most damaging UVB and UVC rays. Without this protective shield, life would be subjected to intense radiation that damages DNA, causes sunburns and skin cancer, and harms phytoplankton, the base of the marine food web. The integrity of this layer was threatened in the late 20th century by human-made chemicals, primarily chlorofluorocarbons, which created a notorious hole over Antarctica. The global response, the Montreal Protocol of 1987, successfully phased out these substances. This landmark international treaty is a testament to our ability to solve global environmental problems, and the ozone layer is now in a slow but steady recovery, showcasing a rare success story in global environmental policy. Fact 15. Air pressure decreases with altitude. The air around us has weight, and the force exerted by the column of air above a given point is what we measure as atmospheric pressure. At sea level, this pressure is standardized as 1013.25 millibars. As you ascend through the atmosphere, the column of air above you becomes shorter and less dense, meaning there are fewer air molecules pressing down from above. Consequently, atmospheric pressure decreases exponentially with altitude. This is why your ears pop when you ascend a mountain or take off in an airplane. Your body is adjusting to the lower external pressure. This rapid decrease in pressure is the reason high-altitude mountains have such thin air, making breathing difficult for climbers without supplemental oxygen. The relationship between pressure and altitude is fundamental to meteorology, as differences in air pressure drive wind patterns and storm development. It also dictates the design of aircraft cabins, which must be pressurized to simulate a lower altitude, and the need for pressurized suits or spacecraft for astronauts venturing into the near vacuum of space. Fact 16. The troposphere is where weather happens. The troposphere is the lowest layer of Earth's atmosphere, extending from the surface up to an average of about 12 kilometers. This relatively thin layer is the stage for all of Earth's weather phenomena. It contains approximately 75% of the atmosphere's total mass and almost all of its water vapor and aerosols. The name troposphere comes from the Greek word tropos, meaning turn or change, which is highly appropriate as it is a zone of constant motion and mixing. The primary driver of weather is the sun, which heats the Earth's surface unevenly. This heating causes air to expand, become less dense, and rise, creating areas of low pressure. Cooler, denser air sinks, creating high-pressure areas. The movement of air from high to low pressure is wind. The decrease in temperature with altitude allows for the condensation of water vapor, leading to cloud formation, precipitation, and storms. The boundary at the top of the troposphere is called the tropopause, which acts as a lid, generally confining weather systems to this dynamic and vital layer. Fact 17. The ionosphere reflects radio waves. The ionosphere is a region of Earth's upper atmosphere, stretching from about 60 kilometers to 1,000 kilometers in altitude, within the thermosphere and exosphere. It is characterized by a high concentration of ions and free electrons, created when intense solar ultraviolet and X-ray radiation knocks electrons off of atoms and molecules. This ionized gas, or plasma, has a unique property. It can reflect certain frequencies of radio waves. This characteristic is crucial for long-distance radio communication. Instead of traveling in a straight line and shooting off into space, high-frequency radio waves can be bounced off the ionosphere and back down to Earth, allowing signals to travel beyond the horizon, sometimes circling the globe. The density and height of the ionospheric layers change between day and night and with solar activity. During the day, solar radiation is more intense, creating more layers and affecting which frequencies can be reflected. This layer is also where the beautiful auroras occur, as solar particles are funneled along magnetic field lines and collide with atmospheric gases, causing them to glow. Fact 18. Earth has a second moon sometimes. While the moon is Earth's only permanent natural satellite, our planet's gravity can temporarily capture small asteroids, causing them to enter a complex orbit around both the Earth and the Sun for a period before they escape. These temporary satellites are known as minimoons or quasi-satellites. The first, and so far only, confirmed minimoon was a small object called 2006 RH120, which orbited Earth for about 18 months from 2006 to 2007 before breaking free. A more recent and famous example is 2020 CD3, a tiny asteroid roughly the size of a car that was captured by Earth's gravity around 2017 and remained in a temporary orbit until early 2020. These objects are typically only a few meters in diameter and are difficult to detect due to their small size and faintness. Their temporary orbits are highly unstable, influenced by the gravitational pulls of the Sun and the Moon. Studying these minimoons is of great interest to scientists, as they provide easy-to-reach targets for future asteroid missions and offer insights into the population of small objects in near-Earth space. Fact 19. Earth is the densest planet in the solar system. With an average density of 5.51 grams per cubic centimeter, Earth holds the title of the densest planet in our solar system. This high density is a direct result of our planet's composition and internal structure. Earth is a terrestrial, or rocky, planet, composed largely of heavy elements like iron, oxygen, silicon, and magnesium. Crucially, its structure is differentiated, meaning these elements have separated into distinct layers based on their density. The heaviest material, primarily iron and nickel, has sunk to form the dense core. The surrounding mantle and crust are composed of lighter silicate rocks. This concentration of mass towards the center significantly increases the planet's overall average density. In comparison, the other terrestrial planets are less dense. Mercury, while having a very large iron core, is less dense overall due to the compressive effect of its smaller mass. Venus and Mars are similar in composition to Earth but have less massive, and therefore less compressed, cores. The gas giants, like Jupiter and Saturn, have much lower average densities. Saturn's density is even less than that of water, meaning it would theoretically float in a vast, cosmic ocean. Fact 20. It is the only planet with plate tectonics. Earth is unique in our solar system as the only planet known to have active plate tectonics. This geological process involves the movement of large, rigid plates that make up the lithosphere, the crust and the uppermost solid part of the mantle. These plates are in constant, slow motion, driven by the convective heat engine of the mantle below. The boundaries between these plates are sites of intense geological activity. Where plates diverge, new crust is formed. Where they converge, crust is destroyed in subduction zones or crumpled into mountains. And where they slide past each other, they create massive fault lines like the San Andreas. This system acts as a global thermostat. Through the carbon silicate cycle, plate tectonics regulates Earth's climate over millions of years by recycling carbon dioxide between the atmosphere, oceans, and rocks. It also drives the creation of continents and ocean basins, concentrates mineral resources, and is likely a key factor in making a planet habitable over geological timescales. While other bodies like Venus and Mars may have had tectonic activity in the past, only Earth exhibits this dynamic, ongoing process today. Fact 21. The Himalayas are still growing. The majestic Himalayas, home to Mount Everest, are not a static relic of the past. They are a dynamic, rising mountain range. This ongoing growth is a direct result of the colossal tectonic collision between the Indian Plate and the Eurasian Plate. Approximately 50 million years ago, the Indian subcontinent, moving northward at a geologically rapid pace, slammed into Asia. This collision has not stopped. The Indian Plate continues to push into Eurasia at a rate of about 4 to 5 centimeters per year. Because both plates are continental crust and have similar density, neither can be easily subducted. Instead, the crust is compressed, crumpled, and forced upward, much like the hood of a car in a head-on collision. This immense force thrusts the mountains skyward at a rate of roughly 1 centimeter per year, which is effectively counterbalanced by erosion from wind, ice, and water. This tectonic struggle also makes the region exceptionally seismically active, with frequent earthquakes as the plates grind against each other and release built-up stress. The Himalayas are a breathtaking testament to the powerful, living forces that continuously reshape our planet's surface. Fact 22. The Pacific Ocean is getting smaller. While the Atlantic Ocean is steadily widening, the Pacific Ocean is undergoing the opposite process and is gradually shrinking. This reduction is driven by the complex dance of plate tectonics. The Pacific Ocean is largely defined by the Pacific Plate, which is surrounded by a boundary known as the Ring of Fire. Along most of its edges, the dense oceanic crust of the Pacific Plate is being subducted, meaning it is plunging beneath the lighter continental plates and other smaller oceanic plates that surround it. For instance, it is subducting beneath South America at the Peru-Chile Trench and under Japan at the Japan Trench. This process consumes the seafloor, pulling it back into the mantle at a rate of a few centimeters per year. As the ocean floor is destroyed at its margins faster than new crust is created at the Pacific-Antarctic Ridge and other small spreading centers, the overall basin contracts. This ongoing subduction is also responsible for the intense volcanic and seismic activity that characterizes the Ring of Fire, creating a ring of volcanoes and earthquake zones that frame the ocean basin. Fact 23. The Atlantic Ocean is getting wider. The Atlantic Ocean is growing wider every year, a process driven by the powerful forces of seafloor spreading. Running roughly north to south down the center of the Atlantic is the Mid-Atlantic Ridge, a massive underwater mountain range. This ridge is a divergent plate boundary, where the North American Plate and the Eurasian Plate are pulling apart in the north, and the South American Plate and the African Plate are separating in the south. As the plates diverge, magma from the underlying mantle wells up into the gap, cools, and solidifies to form new oceanic crust. This continuous addition of new material pushes the older crust outward, effectively widening the Atlantic basin at a rate of about 2.5 to 4 centimeters per year, roughly the speed at which your fingernails grow. This process was a key piece of evidence for the theory of plate tectonics. The symmetrical pattern of magnetic stripes on either side of the ridge, recorded in the volcanic rock as Earth's magnetic field reversed over time, provides a clear tape recording of this seafloor spreading over millions of years. Fact 24. There are underwater volcanoes and mountains. The ocean floor is not a flat, barren plain. It is a dramatic landscape rivaling anything on the continents, dominated by vast volcanic and mountain ranges. The most extensive chain is the global mid-ocean ridge system, a continuous underwater mountain range that winds around the entire planet for over 65,000 kilometers. This is where tectonic plates are pulling apart. A new seafloor is born from countless volcanic eruptions. Beyond this, the ocean basins are dotted with individual seamounts, submarine volcanoes, often formed by hotspots in the mantle. It is estimated there are over 100,000 seamounts taller than 1,000 meters. Some of these volcanoes are massive. Mauna Kea in Hawaii, for example, is the tallest mountain on Earth when measured from its base on the seafloor. These submerged structures are ecological hotspots themselves, as their hard surfaces and upwelling currents support rich and diverse communities of marine life, including deep water corals, sponges, and unique fish species, creating oases of biodiversity in the deep sea. Fact 25. The Ring of Fire circles the Pacific Ocean. The Pacific Ring of Fire is a horseshoe-shaped belt approximately 40,000 kilometers long, bordering the Pacific Ocean. It is the most seismically and volcanically active zone on Earth, home to about 75% of the world's active and dormant volcanoes and the source of roughly 90% of the planet's earthquakes. This ring is not a coincidence but a direct consequence of plate tectonics. It traces the boundaries of the massive Pacific Plate and several smaller adjacent plates. Along most of this boundary, the dense oceanic plates are being subducted beneath the surrounding continental and lighter oceanic plates. As a plate descends into the hot mantle, it releases water, which lowers the melting point of the surrounding rock, generating magma. This magma rises through the overlying plate, fueling a chain of volcanoes parallel to the trench, such as the Cascades in North America and the Japanese archipelago. The grinding and collision of the plates at these subduction zones also create immense friction, leading to the world's most powerful earthquakes, including the 2004 Indian Ocean and 2011 Tohoku earthquakes. Fact 26. Earth has over 1,500 potentially active volcanoes. The United States Geological Survey estimates that there are more than 1,500 volcanoes on Earth that have the potential to become active again, meaning they have erupted in the last 10,000 years, the Holocene epoch, and could erupt in the future. This count includes volcanoes both on land and under the sea. Of these, about 500 have erupted in recorded history. They are not evenly distributed but are concentrated along plate boundaries, particularly the Pacific Ring of Fire, and at hotspots like Hawaii and Yellowstone. On any given day, between 10 and 20 volcanoes are actively erupting somewhere on the planet. These eruptions are a vital part of Earth's geological system. Over long periods, volcanic outgassing helped form Earth's early atmosphere and oceans. Today, they continue to add new land, create fertile soils, and bring valuable minerals to the surface. While posing a significant hazard to nearby populations, monitoring these volcanoes provides crucial insights into the workings of our planet's interior. Fact 27. Most of Earth's volcanoes are underwater. The vast majority of volcanic activity on Earth occurs unseen, hidden beneath the waves of the ocean. Scientists estimate that submarine volcanoes account for about 75% of the total magma output each year. The primary site of this activity is the global mid-ocean ridge system, a massive chain of underwater mountains where tectonic plates are diverging. As the plates pull apart, magma from the mantle continuously rises to fill the gaps, creating new oceanic crust through countless fissure eruptions. This process is the primary driver of seafloor spreading. Beyond the ridges, thousands of individual submarine volcanoes, called seamounts, dot the ocean floor, formed by hotspots or other volcanic activity. While most of these eruptions are slow and steady, rarely posing a direct threat, they play a fundamental role in the Earth system. They chemically alter seawater as it circulates through the hot crust, support unique ecosystems based on chemosynthesis, and are the very factories that build the ocean basins themselves. Fact 28. Earthquakes usually occur at fault lines. An earthquake is the sudden release of accumulated energy in the Earth's crust, which creates seismic waves. The vast majority of these events occur along pre-existing zones of weakness in the crust known as faults. Faults are fractures where blocks of crust have moved relative to each other. They are primarily found at the boundaries of tectonic plates, where immense forces, pushing, pulling, or sliding, cause stress to build up in the rock over decades or centuries. When the stress exceeds the strength of the rock, it slips suddenly, releasing energy in the form of an earthquake. The point where this slip initiates underground is the hypocenter, and the point directly above it on the surface is the epicenter. The San Andreas Fault in California is a famous example of a transform fault, where two plates slide past each other. Not all faults reach the surface, and some earthquakes occur on ancient, dormant faults reactivated by tectonic forces. Understanding the location and behavior of fault lines is crucial for assessing seismic hazard and risk. Fact 29. The deepest place on Earth is the Mariana Trench. Located in the western Pacific Ocean, east of the Mariana Islands, the Mariana Trench is the deepest natural point on Earth. The deepest part of this trench is a small, narrow valley known as the Challenger Deep, which plunges to an incredible depth of nearly 11,000 meters. To put this in perspective, if Mount Everest were placed at the bottom, its peak would still be over 2 kilometers underwater. The trench is formed by the process of subduction, where the Pacific Plate is being forced beneath the smaller Mariana Plate. This creates a vast chasm in the seafloor. The environment there is one of extreme pressure, over 1,000 times standard atmospheric pressure, perpetual darkness, and near-freezing temperatures. Despite these inhospitable conditions, life exists. Expeditions have discovered unique organisms, such as deep-sea snailfish and giant amoebas, adapted to survive in one of the most hostile environments on the planet. The trench remains one of the least explored and most mysterious places on Earth. Fact 30. The highest point is Mount Everest. Situated in the Mahalanga Himal subrange of the Himalayas, Mount Everest is Earth's highest mountain above sea level, with its summit reaching 8,848.86 meters. Its Tibetan name, Chomolungma, means Goddess Mother of the World, reflecting its immense stature. Everest's height is a direct result of the ongoing tectonic collision between the Indian and Eurasian plates, which continues to push the mountain upward. However, it's important to note that highest is different from tallest. While Everest has the highest altitude, the title of tallest mountain from base to summit belongs to Mauna Kea in Hawaii, which rises over 10,000 meters from the Pacific seafloor. The summit of Everest is composed of marine limestone, a testament to the fact that the region was once covered by an ancient sea. Climbing Everest presents extreme challenges, including the death zone above 8,000 meters where oxygen is insufficient to sustain human life for long periods, brutal weather, and treacherous terrain, making it an ultimate goal for mountaineers. Fact 31. The lowest dry point is the Dead Sea. The Dead Sea, a hypersaline lake bordered by Jordan to the east and Israel and the West Bank to the west, holds the distinction of being the lowest dry land point on Earth. Its surface and shores currently sit at approximately 430 meters below sea level, and this depth is increasing by about 1 meter per year due to water diversion from its main tributary, the Jordan River. This extraordinary elevation is a result of its location in the Dead Sea Rift, a tectonic transform fault. The lake itself is not a sea but an endorheic lake, meaning it has no outlet, and water only leaves through evaporation. This process leaves behind a dense, rich cocktail of minerals, including sodium, magnesium, calcium, and potassium, making the water about 9.6 times saltier than the ocean. This extreme salinity creates a harsh environment where macroscopic aquatic organisms cannot live, hence its name, and provides such buoyancy that swimmers float effortlessly on its surface. Fact 32. There are mountains under the sea. The ocean floor conceals a dramatic and vast mountainous landscape that rivals, and in many ways surpasses, those found on the continents. The most extensive mountain range on Earth is not the Andes or the Himalayas, but the continuous, globe-encircling mid-ocean ridge system. This underwater behemoth stretches for over 65,000 kilometers, winding through all the ocean basins. It is formed by tectonic forces at divergent plate boundaries, where plates are pulling apart and magma wells up from the mantle to create new oceanic crust, building a continuous chain of volcanic mountains. In addition to this massive ridge, the seafloor is dotted with countless individual seamounts, submarine volcanoes, often formed by hotspots. Some of these, like the Hawaiian Emperor Seamount chain, are immense. Mauna Kea, a Hawaiian volcano, is the tallest mountain on Earth from its base on the seafloor to its summit. Fact 33. The mid-ocean ridge is the longest mountain range. Snaking its way through every ocean on the planet, the mid-ocean ridge system is the longest mountain range in the world, with a total length exceeding 65,000 kilometers. This is more than 10 times the length of the Andes, Rockies, and Himalayas combined. This mostly submerged range is the site of one of Earth's most fundamental geological processes, seafloor spreading. At the ridge's crest, tectonic plates are pulling apart, causing a rift in the lithosphere. This divergence allows hot magma from the asthenosphere to rise, erupt, and cool, continuously forming new oceanic crust. The process builds a characteristic ridge of mountains with a central rift valley. The system is not a continuous, smooth line but is offset by numerous transform faults. This global ridge system is the engine of plate tectonics, constantly renewing the ocean floor and pushing continents across the globe. It is also home to unique deep-sea vent ecosystems that thrive on chemical energy rather than sunlight. Fact 34. Earth's rotation is gradually slowing down. The Earth's rotation, which gives us the cycle of day and night, is not constant. It is very gradually slowing down over geological time. The primary mechanism for this deceleration is the gravitational interaction between the Earth and the Moon, specifically the tidal forces. The Moon's gravity pulls on Earth's oceans, creating tidal bulges. Because Earth rotates faster than the Moon orbits, our planet tries to drag these bulges ahead of the Moon. The Moon's gravity pulls back on these bulges, acting as a very slight brake on Earth's spin. This transfer of angular momentum causes the Moon to slowly recede from Earth at about 3.8 centimeters per year. The slowing is minimal, adding about 2.3 milliseconds to the length of a day per century. This means that in the time of the dinosaurs, a day was only about 23 hours long. Evidence from ancient eclipse records and fossil growth rings in corals confirms this long-term trend, although short-term variations from atmospheric and oceanic processes can also affect the rotation rate. Fact 35. A day was only 18 hours long ago. Hundreds of millions of years ago, a day on Earth was significantly shorter than the 24 hours we experience now. During the Ediacaran period, around 620 million years ago, a day lasted only about 22 hours. Going back even further, to the Proterozoic Eon over a billion years ago, a day may have been as short as 18 to 20 hours. This is a direct consequence of Earth's faster rotation in the past, which has been gradually slowing down due to tidal friction caused by the Moon's gravity. The Moon's gravitational pull creates tidal bulges on Earth. Our planet's rotation tries to pull these bulges ahead, but the Moon's gravity pulls them back, creating a constant, slight braking force. This process transfers rotational energy from Earth to the Moon, slowing our spin and pushing the Moon into a higher orbit. Scientists have confirmed this by studying the growth patterns in fossilized corals and mollusks, which record daily and annual cycles, providing a paleontological clock that reveals the length of days in the deep past. Fact 36. Earth's tilt causes the seasons. The primary reason for the changing seasons is the 23.5-degree axial tilt of the Earth, not its varying distance from the Sun. As Earth orbits the Sun throughout the year, this tilt causes different parts of the planet to receive direct solar radiation for more or less of the day. During the June solstice, the North Pole is tilted toward the Sun, resulting in the Northern Hemisphere experiencing summer with longer days and more direct sunlight. Simultaneously, the South Pole is tilted away, experiencing winter with shorter days and less direct light. 6 months later, during the December solstice, the situation is reversed. The equinoxes in March and September occur when the tilt is sideways to the Sun, and both hemispheres receive roughly equal amounts of sunlight. This tilt is responsible for the dramatic seasonal variations in temperature, weather patterns, and daylight hours that characterize life outside the tropics. Without this tilt, there would be no seasons, and every day would be much like the last in terms of light and temperature. Fact 37. We are moving at 107,000 kilometers per hour around the Sun. While we feel stationary on the Earth's surface, our planet is carrying us on a breathtakingly fast journey around the Sun. Earth's orbital speed averages about 107,000 kilometers per hour, or roughly 30 kilometers per second. This incredible velocity is necessary to maintain a stable orbit around the Sun, balancing the Sun's powerful gravitational pull with our planet's forward momentum. It takes 1 year, approximately 365.25 days, to complete this nearly circular elliptical journey of about 940 million kilometers. This motion is compounded by other movements. Our solar system is orbiting the center of the Milky Way galaxy at an even more staggering 720,000 kilometers per hour, and the galaxy itself is moving through the universe. We are unaware of this constant, high-speed motion because we are moving along with the Earth in a constant frame of reference, and there is no surrounding air or fixed points in space to create a sensation of speed, much like a passenger on a smooth-flying jetliner. Fact 38. The Earth is 4.54 billion years old. Scientists have determined the age of the Earth to be approximately 4.54 billion years, with a margin of error of about 50 million years. This precise dating is primarily derived from radiometric dating of the oldest rocks found on Earth, such as the Acasta gneiss in Canada, and, more reliably, from meteorites. The most consistent age comes from lead isotopes in meteorites, particularly the Canyon Diaoolo meteorite, which are considered to be leftover material from the early solar system. Since all bodies in the solar system formed around the same time from the same solar nebula, dating these meteorites gives us the age of the Earth itself. This vast age, known as the deep time concept, is divided into a formal geological timescale that chronicles the planet's dramatic history, from its molten beginnings and the formation of the first continents, to the rise of life, the evolution of complex organisms, and the relatively recent emergence of humans. This timeline provides the essential context for understanding all geological and biological processes. Fact 39. The oldest known rock is 4.4 billion years old. The oldest known intact rock formation on Earth is the Acasta gneiss, found in the Canadian Northwest Territories near the Great Slave Lake. Radiometric dating using uranium lead methods has determined its age to be about 4.03 billion years. However, individual mineral grains, known as detrital zircons, found in younger sedimentary rocks in the Jack Hills of Western Australia, hold the record for the oldest known Earth material. These incredibly durable zircon crystals have been dated to 4.4 billion years old. This is a profound discovery because it indicates that solid crust formed on Earth very soon after its accretion and the giant impact that formed the Moon, which occurred around 4.5 billion years ago. The chemical composition of these ancient zircons even suggests the presence of liquid water on the surface at that time, pushing back the possible timeline for the emergence of habitable conditions on our planet to a very early stage in its history. Fact 40. The first life appeared 3.7 billion years ago. Evidence from the geological record indicates that life emerged on Earth surprisingly early in its history. The oldest widely accepted evidence of life comes from fossilized microbial mats, known as stromatolites, found in 3.7 billion-year-old rocks in Greenland. These structures are formed by colonies of cyanobacteria, which trap and bind sediment. Even older, more contested evidence from 4.1 billion-year-old zircons in Australia suggests potential biological activity based on a specific carbon isotope signature. This rapid appearance of life, relatively soon after the planet cooled and formed a solid crust, suggests that the emergence of simple, single-celled organisms may be a common process in the universe given the right conditions. These first life forms were prokaryotes, simple cells without a nucleus, and they were almost certainly anaerobic, as Earth's early atmosphere lacked oxygen. They laid the foundational biological groundwork for all future evolution on the planet. Fact 41. Earth's water is older than the Sun. A significant portion of the water on Earth, and indeed throughout our solar system, is older than the Sun itself. This remarkable conclusion comes from studying the ratio of heavy water, which contains deuterium, a heavier isotope of hydrogen, to regular water. This specific deuterium to hydrogen ratio found in Earth's oceans, comets, and meteorites is a chemical fingerprint that can only be formed in the extreme cold of the interstellar molecular cloud that gave birth to our solar system. When the solar system began forming 4.6 billion years ago from the collapse of this cloud, the pre-existing ice grains were preserved in the cold outer regions. These icy particles were then incorporated into comets and asteroids, which later bombarded the early Earth, delivering their ancient water cargo. This means the molecules in your glass of water have a history stretching back over 4.6 billion years, predating the ignition of our Sun. They were forged in the frigid expanse of space and journeyed across the solar system before becoming part of our world's life-sustaining hydrosphere. Fact 42. Oxygen was a poison to early life. For the first half of Earth's history, the atmosphere contained virtually no free oxygen. Early life consisted of anaerobic microbes for whom oxygen was a toxic waste product. This changed dramatically with the evolution of cyanobacteria around 2.4 to 2.7 billion years ago. These organisms developed photosynthesis, a process that uses sunlight, water, and carbon dioxide to produce energy, releasing oxygen as a byproduct. This event, known as the Great Oxidation Event, was a catastrophe for most existing life, causing a mass extinction of anaerobic organisms. The released oxygen first reacted with dissolved iron in the oceans, creating vast deposits of banded iron formations visible today. Once the oceans were saturated, oxygen began accumulating in the atmosphere, permanently changing its composition. While toxic to many, this environmental crisis ultimately paved the way for complex, oxygen-breathing life. The rise of oxygen allowed for the development of aerobic respiration, a much more efficient way to produce energy, which was a prerequisite for the evolution of larger, more complex multicellular organisms. Fact 43. Earth's continents were once a supercontinent. The continents we know today are fragments of a giant landmass that existed around 335 to 175 million years ago, known as Pangaea. This supercontinent was surrounded by a single global ocean called Panthalassa. The theory of Pangaea was first proposed by Alfred Wegener, who noticed the jigsaw-like fit of continental coastlines, such as the east coast of South America and the west coast of Africa. He also found matching fossil distributions and geological formations across these now separated continents. Pangaea began breaking apart during the Mesozoic era, driven by the process of plate tectonics. Rifts formed, and the landmass fragmented into Laurasia in the north and Gondwana in the south, which subsequently broke apart further to form the modern continents. This cycle of supercontinent formation and breakup, known as the supercontinent cycle, has likely occurred multiple times in Earth's history. The continents are still moving today, and in another 250 million years, a new supercontinent, often called Pangaea Proxima or Amasia, is projected to form. Fact 44. The Moon was created by a giant impact. The prevailing scientific theory for the Moon's origin is the giant impact hypothesis. This proposes that shortly after Earth's initial formation, about 4.5 billion years ago, a Mars-sized planetesimal named Theia collided with the proto-Earth. The impact was not a direct hit but a glancing blow, which was catastrophic. Theia was utterly destroyed, and a significant portion of Earth's mantle was vaporized and blasted into orbit around our planet. This ejected material, a disk of molten rock and vapor, quickly coalesced through gravitational attraction to form the Moon. This theory explains key observations. The Moon's composition is very similar to Earth's mantle. It is depleted in heavy iron and volatile elements. It has a relatively small core, and the angular momentum of the Earth-Moon system fits such a violent origin story. This formative event was crucial for Earth's future, stabilizing its axial tilt and creating the tides that may have played a role in the development of early life. Fact 45. The Moon is moving away from Earth. The Moon is slowly receding from Earth at a rate of approximately 3.8 centimeters per year. This distance is measured with extreme precision using laser reflectors left on the lunar surface by Apollo astronauts. The mechanism driving this recession is tidal friction. The Moon's gravity creates a tidal bulge in Earth's oceans, and to a lesser extent, its solid body. Because Earth rotates faster than the Moon orbits, our planet's rotation drags this tidal bulge slightly ahead of the point directly under the Moon. This bulge exerts a gravitational pull on the Moon, subtly tugging it forward in its orbit, which transfers rotational energy from Earth to the Moon. This energy transfer causes the Moon to spiral outward into a higher orbit while simultaneously causing Earth's rotation to slow down, lengthening our day. In the distant past, the Moon was much closer, and days were significantly shorter. This process will continue until Earth's rotation becomes tidally locked with the Moon, meaning a day on Earth will equal a lunar month, though this will take billions of years. Fact 46. Without the Moon, Earth would wobble wildly. The Moon's gravitational influence acts as a crucial stabilizer for Earth's axial tilt, which is the angle between our planet's rotational axis and its orbital plane. This tilt, currently at a stable 23.5 degrees, is responsible for our predictable seasons. Without the Moon's stabilizing torque, gravitational tugs from the Sun and other planets, especially Jupiter, would cause chaotic and large-scale variations in Earth's tilt over geological time. Simulations suggest this could lead to the axial tilt shifting anywhere from 0 to as much as 85 degrees. Such extreme variations would have catastrophic consequences for climate stability. A near-zero tilt would eliminate seasons, while a high tilt would cause extreme seasonal contrasts, with parts of the globe experiencing months of continuous sunlight followed by months of total darkness. This instability would make the evolution of complex life far more difficult. The Moon's presence has provided a stable climatic environment for billions of years, which was likely a critical factor in allowing life to flourish and evolve into the complex forms we see today. Fact 47. Earth is not named after a Greek or Roman god. Unlike the other planets in our solar system, whose names are derived from Roman deities, the name Earth is a notable exception. It comes from the Old English and Germanic words eorth and erda, which simply mean ground or soil. This makes it the only planet in our solar system not named after a figure from Greco-Roman mythology. The Roman equivalent was Terra or Tellus, which also mean earth or land. The reason for this is historical context. For ancient cultures, the other planets were wandering points of light in the sky, while our own world was the solid ground beneath their feet. It was perceived as the central realm of human existence, distinct from the celestial bodies. By the time the convention of naming planets after mythological gods was firmly established, the name Earth was already deeply ingrained in the English language. The international scientific community often uses the Latin terra in terms like terrestrial, but the common name in English remains the simple, ancient word for our home. Fact 48. The name Earth means the ground. The name for our planet has deep roots in the everyday language of ancient peoples. It originates from the Old English word eorth and the Germanic eartha, both of which mean soil, ground, or dry land. This is in stark contrast to the names of the other 7 planets, which are all derived from gods in Roman mythology: Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune. This distinction highlights how our ancestors perceived the world. The Earth was the tangible, physical realm of human life, while the celestial bodies were distant, mysterious lights. The Greek equivalent was Gaia, a primordial goddess personifying the Earth, and the Latin was Terra or Tellus. While these are personifications, the core meaning remains land. The simplicity of the name Earth reflects its fundamental nature to human existence. It was the ground we walked on, the soil we farmed, and the foundation of our world long before we understood it as a planet orbiting a star. Fact 49. 71% of Earth's surface is covered in water. Earth is often called the blue planet for a compelling reason. Approximately 71% of its surface is covered by water. This vast global ocean is divided by the continents into 5 major basins: the Pacific, Atlantic, Indian, Southern, and Arctic Oceans. The Pacific Ocean alone covers more area than all of Earth's landmasses combined. This abundance of surface water is a defining characteristic of our planet and is unique in the solar system. It is the foundation of the hydrosphere, which interacts with the atmosphere, geosphere, and biosphere to create a dynamic and habitable world. The oceans regulate global climate by absorbing and redistributing solar heat, drive weather patterns through evaporation, and are the primary source of the water cycle. Furthermore, they are the cradle of life, having hosted the first living organisms and continuing to support an immense portion of Earth's biodiversity. This overwhelming presence of water is the most visible feature from space and the key to Earth's life-sustaining nature. Fact 50. 97% of Earth's water is salty. While Earth is a water-rich planet, the vast majority of this water is not directly usable for human consumption or agriculture. A staggering 97% of all water on Earth is found in the oceans and is saline. This saltiness comes from the weathering of rocks on land, which releases minerals and salts that are carried by rivers into the ocean. Over billions of years, this process has concentrated salts, primarily sodium chloride, in the seawater. The remaining 3% is freshwater, but this is further distributed in mostly inaccessible forms. About 2.5% of the global water is locked up in glacier, ice caps, and permanent snow, predominantly in Antarctica and Greenland. This leaves only about 0.5% of all Earth's water as accessible freshwater found in groundwater aquifers, lakes, rivers, and the atmosphere. This tiny fraction supports virtually all terrestrial life and human civilization, highlighting the critical importance of conserving and protecting our limited freshwater resources. Fact 51. Only 3% of Earth's water is fresh. Despite Earth's blue planet moniker, only a minuscule fraction of its water is fresh and readily available for terrestrial life. A mere 3% of the planet's total water supply is freshwater, while the overwhelming majority, 97%, is saline and resides in the oceans. This 3% figure is itself a bit misleading, as the majority of this freshwater is not easily accessible. Over 2/3 of it is locked away in a frozen state within glacier, ice caps, and permanent snow cover, primarily in Antarctica and Greenland. Another significant portion is stored deep underground in aquifers. The readily available surface freshwater, found in lakes, rivers, swamps, and the atmosphere, accounts for less than 1% of all freshwater, or about 0.03% of the Earth's total water. This tiny, vital sliver of the global hydrosphere is what supports almost all human needs, from drinking and agriculture to industry and sanitation, underscoring the critical importance of its conservation and sustainable management. Fact 52. Most freshwater is locked in ice. Contrary to the image of freshwater flowing in rivers and filling lakes, the largest reservoir of freshwater on Earth is actually frozen. Approximately 68.7% of the planet's freshwater is stored in glacier, ice caps, and permanent snowfields. The vast ice sheets of Antarctica alone hold about 90% of the world's ice and 70% of its freshwater. Greenland's ice sheet is the second largest repository. This frozen freshwater plays a critical role in the global climate system. The bright white surface of the ice reflects a significant amount of solar radiation back into space, helping to regulate Earth's temperature, a process known as the albedo effect. Furthermore, the slow release of meltwater from glacier feeds rivers that provide water for billions of people, particularly in Asia and South America. The ongoing melting of these ice reserves due to climate change is contributing to global sea level rise and threatens the long-term stability of this vital freshwater bank. Fact 53. Earth has about 1.386 billion cubic kilometers of water. The total volume of water on Earth is a staggering 1.386 billion cubic kilometers. This immense quantity is difficult to visualize, but it underscores the planet's status as a water world. However, this water is very unevenly distributed. The vast majority, about 1.338 billion cubic kilometers, is saline ocean water. The remaining freshwater, approximately 48 million cubic kilometers, is split across various reservoirs. As previously noted, most of this freshwater is frozen in ice sheets and glacier, over 24 million cubic kilometers. Groundwater accounts for another large portion, with about 23.4 million cubic kilometers, though much of this is deep and not economically extractable. The water in all the world's lakes, both fresh and saline, totals about 176,000 cubic kilometers. Soil moisture adds about 16,500 cubic kilometers. Atmospheric water vapor is around 12,900 cubic kilometers. And the water in all rivers at any given moment is a surprisingly small 2,120 cubic kilometers. This distribution highlights that while water is abundant globally, the most accessible forms for life are incredibly scarce. Fact 54. There is water vapor in the atmosphere. The atmosphere, while seemingly empty, contains a significant amount of water in its gaseous form, known as water vapor. This invisible gas is a crucial component of the hydrologic cycle and the Earth's climate system. The total volume of atmospheric water vapor is relatively small compared to the oceans, but it is this vapor that condenses to form clouds, fog, and precipitation. The amount of water vapor the air can hold is highly dependent on temperature. Warm air can hold much more moisture than cold air, which is why tropical regions feel humid and polar regions feel dry. Water vapor is also the most abundant and powerful greenhouse gas. It traps heat radiating from the Earth's surface, providing a natural warming effect that keeps the planet habitable. However, it also creates a powerful feedback loop. As global temperatures rise due to increased CO2, more water evaporates, which in turn traps more heat, amplifying the initial warming, a process known as the water vapor feedback. Fact 55. Groundwater is a vast hidden resource. Beneath the Earth's surface lies a massive, hidden reservoir of freshwater known as groundwater. It is stored in the pores, cracks, and spaces within soil, sand, and rock formations called aquifers. This resource constitutes about 30% of the world's freshwater, with the majority of the rest being ice. It is the primary source of drinking water for nearly half the world's population and is vital for irrigation in agriculture. Groundwater is recharged slowly, primarily from precipitation that infiltrates the ground. This slow recharge rate means that many major aquifers are being depleted much faster than they are naturally replenished, a phenomenon known as groundwater mining. Overpumping can lead to serious consequences, including land subsidence, the sinking of the ground, reduced water flow in rivers and streams connected to the aquifer, and the intrusion of saltwater in coastal areas. Sustainable management of this critical, out-of-sight resource is essential for global water security. Fact 56. Some lakes can explode. In a rare and terrifying phenomenon known as a limnic eruption, a lake can suddenly release a massive cloud of suffocating carbon dioxide. This occurs in meromictic lakes, which have stable layers of water that do not mix. In certain volcanic regions, like Cameroon, CO2 from magma below can seep into the deep waters of such lakes, dissolving under pressure to form a dense, carbonated layer. A trigger, such as a landslide, earthquake, or even a volcanic eruption, can cause this pressurized gas to suddenly erupt from the lake, much like opening a shaken soda bottle. Because CO2 is denser than air, the gas cloud flows down valleys, displacing breathable air and suffocating wildlife and humans. The only known large-scale limnic eruptions occurred at Lake Manoon in 1984 and Lake Nyos in 1986 in Cameroon, the latter releasing an estimated 1.6 million tons of CO2 and causing over 1,700 fatalities. Scientists now use degassing pipes in these lakes to slowly and safely release the CO2 and prevent future disasters. Fact 57. There are rivers and lakes under the ocean. On the seafloor, particularly in confined basins, there exist fascinating features known as brine pools. These are depressions filled with water that is so much saltier and denser than the surrounding seawater that it does not easily mix, forming distinct lakes and rivers with shorelines and waves. The hypersaline brine is created when salt deposits, formed from ancient evaporated seas, dissolve. Because the brine is denser, it sinks and collects in seafloor depressions. The brine is often toxic, devoid of oxygen, and can contain high concentrations of methane and hydrogen sulfide, creating an extreme environment where only specialized extremophile microbes can survive. These underwater lakes can have their own tides and waves as the dense brine sloshes within its basin. They are often surrounded by mussel beds and other life that thrives on the chemosynthetic energy from the seeping chemicals, creating eerie, isolated oases of life on the abyssal plain. Fact 58. The Nile is the longest river on Earth. Flowing northwards through northeastern Africa, the Nile River is widely recognized as the longest river in the world. While its exact length has been a subject of debate, it is generally accepted to stretch for approximately 6,650 kilometers. Its major tributaries are the White Nile, which originates from Lake Victoria in East Africa, and the Blue Nile, which originates from Lake Tana in Ethiopia. These two rivers meet near Khartoum, Sudan, to form the main Nile, which continues through Egypt and empties into the Mediterranean Sea via a vast delta. The Nile has been the lifeline of civilization for thousands of years, with the ancient Egyptian empire flourishing entirely on its banks. Its annual flooding deposited rich silt, making the river valley exceptionally fertile. Today, the river remains a critical water source for 11 countries, and its flow is heavily managed by massive dams, most notably the Aswan High Dam in Egypt, which created Lake Nasser. Fact 59. The Amazon has the largest water flow. While the Nile is the longest river, the Amazon in South America is the undisputed king by volume. It discharges an astonishing average of 209,000 cubic meters of water per second into the Atlantic Ocean, which is greater than the next 7 largest independent rivers combined. This massive flow accounts for about 20% of the world's total riverine discharge into the oceans. During the wet season, the river can be over 190 kilometers wide at its mouth, and the force of its freshwater push is so powerful that it dilutes the ocean's salinity for hundreds of kilometers offshore. The Amazon's vast basin, covering approximately 7 million square kilometers, is the largest drainage basin in the world. Its flow is so immense that it has a significant impact on regional and potentially global climate and ocean salinity patterns. The river is also a biodiversity hotspot, home to countless species of fish, including the piranha and the Amazon river dolphin, and its flooded forests are a unique and vital ecosystem. Fact 60. Antarctica is a desert. Despite being covered in a sheet of ice that holds 90% of the world's fresh water, Antarctica is technically a desert. A desert is defined by its low annual precipitation, not its temperature. Antarctica receives, on average, only 166 millimeters of precipitation, in water equivalent, per year, primarily as snow. The continent's interior is one of the driest places on Earth, with some areas, known as the dry valleys, having seen no rainfall for nearly 2 million years. The extreme cold air holds very little moisture, making precipitation a rare event. The little snow that does fall does not melt but accumulates over millennia, compressing into the massive ice sheet we see today. This combination of frigid temperatures and extremely low precipitation creates a polar desert environment that is even drier than the Sahara. The misconception arises because its water is stored in a solid state, but by meteorological definition, Antarctica is the largest, coldest, and windiest desert on the planet. Fact 61. Antarctica holds 90% of the world's ice. The Antarctic ice sheet is the single largest mass of ice on Earth, containing a staggering 90% of the planet's freshwater in a frozen state. This immense sheet is, on average, 2.2 kilometers thick, but in some places, the ice plunges to depths of nearly 5 kilometers. If all of this ice were to melt, it would raise global sea levels by approximately 60 meters, dramatically reshaping the world's coastlines and submerging major cities. The ice sheet is not a static monolith. It flows slowly towards the coast under its own weight, forming massive ice shelves that extend over the ocean. These shelves, such as the Ross and Ron ice shelves, act as buttresses, slowing the flow of the inland ice. The stability of this frozen continent is therefore critical to global sea level. Scientists closely monitor its health, as increasing melt rates and the carving of gigantic icebergs are key indicators of climate change and have profound implications for the future. Fact 62. Antarctica holds 70% of Earth's freshwater. While 97% of Earth's water is saline, the remaining 3% is freshwater. Of this precious 3%, a colossal 70% is locked away in the Antarctic ice sheet. This fact highlights the incredible concentration of our planet's most vital resource in one of its most inaccessible places. The volume of ice is so immense that it exerts enough pressure to depress the continental bedrock beneath it, pushing it hundreds of meters below sea level. This freshwater is stored in a state that is largely unusable for human consumption or agriculture without an enormous input of energy to melt it. The sheer scale of this frozen reservoir means that Antarctica plays the most significant role in the global freshwater cycle. Any significant change in its mass balance, the difference between snowfall accumulation and ice loss, directly impacts global sea levels. This makes the continent a primary focus for climate science, as its fate is inextricably linked to the future availability and distribution of freshwater worldwide. Fact 63. The Sahara is the largest hot desert. Covering an area of approximately 9.2 million square kilometers, the Sahara Desert in North Africa is the world's largest hot desert, rivaling the size of the entire United States. Its vast expanse of sand dunes, stone plateaus, and gravel plains is characterized by extreme aridity and some of the highest temperatures ever recorded on Earth. However, the Sahara's climate has not always been so harsh. Paleoclimatic evidence, such as rock art and fossilized remains, reveals that it underwent a green Sahara phase several times in its history, most recently between 11,000 and 5,000 years ago, when it was a savanna with lakes and rivers supporting a diversity of wildlife and human populations. The desert is also expanding southward due to a process known as desertification, influenced by both natural climate cycles and human activities. Despite its harsh conditions, the Sahara is not lifeless, hosting adapted species like fennec foxes, addax antelopes, and nomadic human cultures. Fact 64. Deserts can be cold. The common perception of a desert is a hot, sandy landscape, but the defining characteristic of a desert is actually low precipitation, not high temperature. A desert is any region that receives less than 250 millimeters of precipitation per year. This definition includes the vast polar deserts of Antarctica and the Arctic. Antarctica, for instance, is the largest desert on Earth. These cold deserts experience extremely low temperatures that freeze the little moisture in the air, resulting in very little snowfall. Other examples of cold deserts include the Gobi Desert in Central Asia and the Great Basin Desert in the United States. These regions can experience scorching summers and freezing winters, but their annual precipitation remains minimal. The life that exists in cold deserts is highly specialized to survive both aridity and extreme cold, often involving deep root systems, water storing adaptations, and behaviors to escape temperature extremes, demonstrating the remarkable diversity of desert ecosystems beyond the iconic sand dunes. Fact 65. Permafrost stores vast amounts of carbon. Permafrost, ground that remains completely frozen for at least 2 consecutive years, underlies about a quarter of the northern hemisphere's land surface. This frozen soil is not just dirt and ice, it is a massive reservoir of ancient organic carbon, composed of the remains of plants and animals that have been locked in a deep freeze for thousands of years. Scientists estimate that the permafrost stores nearly twice as much carbon as is currently present in the atmosphere. As global temperatures rise, the permafrost thaws, allowing microbes to decompose this previously frozen organic matter. This process releases greenhouse gases, carbon dioxide and methane, into the atmosphere. This creates a dangerous feedback loop known as the permafrost carbon feedback. Warming causes thawing, which releases more greenhouse gases, which in turn causes more warming. The thawing permafrost also destabilizes the ground, damaging infrastructure and releasing ancient viruses and bacteria, making it a critical and vulnerable component of the climate system. Fact 66. Soil is a living, breathing ecosystem. Beneath our feet lies one of the most biodiverse habitats on Earth, the soil. It is not merely inert dirt but a complex, living ecosystem teeming with organisms. A single teaspoon of healthy soil can contain billions of bacteria, miles of fungal filaments, thousands of protozoa, and dozens of nematodes, not to mention larger creatures like mites, springtails, and earthworms. These organisms form a complex food web that drives essential nutrient cycles. Decomposers like bacteria and fungi break down organic matter, releasing nutrients that plants can absorb. Mycorrhizal fungi form symbiotic relationships with plant roots, dramatically increasing their ability to absorb water and nutrients. Earthworms and insects aerate the soil and mix its layers. This incredible biological activity makes soil a dynamic, breathing entity that is fundamental to life on land, supporting agriculture, filtering water, and sequestering carbon. Protecting soil health is therefore synonymous with protecting the foundation of our terrestrial biosphere. Fact 67. Earth has more than 12 soil types. Soil is classified into various types based on its composition, texture, structure, and color. The USDA soil taxonomy, a common classification system, identifies 12 major soil orders, but this is a simplification of a far more diverse reality. These orders include familiar types like alphisols, fertile forest soils, aridisals, desert soils, mollisols, prairie grasslands with thick, dark topsoil, and oxysols, highly weathered tropical soils. Each order is further divided into suborders, great groups, subgroups, families, and series, resulting in over 20,000 distinct soil series identified in the United States alone. The type of soil that forms in a region is influenced by 5 key factors: parent material, the underlying geology, climate, topography, organisms, and time. This incredible diversity means that soil properties can change dramatically over short distances, influencing what crops can be grown, how water drains, and what ecosystems can be supported in a given area. Fact 68. A teaspoon of soil contains billions of organisms. The biodiversity within soil is so immense that it rivals that of tropical rainforests. A single teaspoon of healthy agricultural soil can be home to between 100 million and 1 billion individual bacteria, representing thousands of different species. This same teaspoon will also contain several meters of fungal hyphae, filaments, tens of thousands of protozoa, and hundreds of nematodes. This microscopic world is a bustling metropolis where countless interactions take place. Bacteria and fungi are the primary decomposers, breaking down complex organic matter. Protozoa and nematodes act as predators, grazing on the bacteria and fungi, which releases nutrients in a form plants can use. This intricate food web is essential for nutrient cycling, soil structure formation, and disease suppression. The health of this hidden ecosystem directly impacts the health of the plants growing in it, making it the foundation of terrestrial food webs and a critical resource for sustainable agriculture. Fact 69. Earth's forests are its lungs. Often called the lungs of the planet, forests play a critical role in regulating Earth's atmosphere through the process of photosynthesis. During this process, trees and other plants absorb carbon dioxide from the atmosphere and, using energy from sunlight, convert it into carbohydrates for growth, releasing oxygen as a byproduct. This function is vital for mitigating climate change, as forests act as massive carbon sinks, sequestering billions of tons of carbon annually. However, the analogy of lungs is not perfect, as forests also respire, consuming oxygen and releasing CO2, especially at night. The net effect, however, is a significant removal of CO2 and production of oxygen. Beyond this, Forests influence local and global climate patterns by regulating water cycles, providing cloud cover, and cooling the air through transpiration. They also harbor most of the world's terrestrial biodiversity. The preservation and restoration of the world's forests are therefore crucial for maintaining atmospheric balance and a stable climate. Fact 70. The Amazon produces 20% of Earth's oxygen. The Amazon rainforest is frequently credited with producing 20% of the world's oxygen, a statistic that highlights its global importance. This oxygen is a byproduct of photosynthesis performed by the vast number of trees and plants in the basin. However, this figure requires important context. While the Amazon generates a massive amount of oxygen during the day, much of it is consumed at night by plant respiration and, more significantly, by the decomposition of immense quantities of organic matter on the forest floor by microbes. The net production of oxygen that actually escapes into the atmosphere and is available for other life forms is much lower. In fact, mature, stable forests like the Amazon are often nearly carbon neutral over annual cycles. The real, irreplaceable value of the Amazon lies not in its net oxygen output but in its role as a massive storehouse of carbon, its regulation of regional and global weather patterns, and its status as the planet's greatest reservoir of terrestrial biodiversity. Fact 71. Phytoplankton produce over half the oxygen. While forests are vital, the true lungs of the planet are microscopic marine plants called phytoplankton. These tiny, photosynthetic organisms that drift in the upper layers of the ocean are responsible for producing between 50% and 80% of the Earth's oxygen. Through photosynthesis, they consume carbon dioxide and release oxygen on a massive scale. Their collective output is so immense that it dwarfs that of all the world's rainforests combined. The health of these microscopic communities is therefore directly linked to the composition of our atmosphere. Phytoplankton form the base of the marine food web, supporting everything from tiny zooplankton to the largest whales. Furthermore, when they die, some sink to the deep ocean, sequestering carbon for centuries in a process known as the biological carbon pump. This makes them crucial not only for the air we breathe but also for regulating the global climate. Their populations are sensitive to changes in ocean temperature, acidity, and nutrient availability, making them a key indicator of planetary health. Fact 72. Life exists in the deepest ocean trenches. The Hadal Zone, the deepest part of the ocean in trenches below 6,000 meters, was once thought to be a lifeless desert due to extreme pressure, perpetual darkness, and cold temperatures. However, expeditions have revealed that life not only exists but thrives in these crushing depths. Specialized organisms have adapted to pressures over 1,000 times that at sea level. Unique species of snailfish, amphipods, and giant single-celled organisms called xenophyrophores call these trenches home. The base of this food web is not sunlight, but chemical energy. Nutrient-rich detritus, known as marine snow, drifts down from above, while in some areas, chemosynthetic bacteria harness energy from methane and hydrogen sulfide seeping from the seafloor. These bacteria support communities of clams, tube worms, and other life, creating isolated oases in the abyss. The discovery of life in the Mariana Trench proves that life is tenacious and can adapt to the most extreme environments on Earth. Fact 73. Life exists in boiling hot springs. In the scorching, acidic waters of hydrothermal vents and terrestrial hot springs, life flourishes where it was once deemed impossible. These extreme environments, with temperatures often exceeding 100 degrees Celsius, are home to hyperthermophiles, microbes that not only survive but require these intense heats to live. They belong to the domain Archaea, some of the most ancient life forms on Earth. These organisms possess specially adapted enzymes and cell membranes that do not break down under extreme heat. At deep-sea vents, the entire ecosystem is based on chemosynthesis, where bacteria use hydrogen sulfide or other chemicals spewing from the Earth's crust as an energy source, rather than sunlight. These bacteria form the base of a food web that includes giant tube worms, blind shrimp, and heat-tolerant crabs. The discovery of these ecosystems revolutionized biology, expanding our understanding of the limits of life and providing a model for how life might arise on other planets with similarly harsh conditions. Fact 74. The deepest life was found 5 kilometers underground. The biosphere extends far deeper into the Earth than previously imagined. Scientists have discovered microbial life thriving up to 5 kilometers below the continental surface and even deeper beneath the ocean floor. This vast subterranean ecosystem, known as the deep biosphere or the intraterrestrial life, may contain a significant portion of the planet's total biomass, with some estimates suggesting it could rival all life on the surface. These deep-dwelling microbes, mostly bacteria and archaea, live in pores and fissures within solid rock, surviving under immense pressure, high temperatures, and in complete darkness. They have incredibly slow metabolic rates, often living for thousands of years on a single meal. They derive energy not from the sun, but from chemosynthesis, processing minerals like iron, sulfur, and methane from the surrounding rock. This discovery has profound implications, suggesting that life could be possible in the subsurface of other planets like Mars and redefining the habitable boundaries of our own world. Fact 75. There are more organisms in soil than people. The biodiversity within soil is so immense that it defies comprehension. The number of individual living organisms in a single handful of fertile soil is greater than the number of human beings who have ever lived. This hidden world is dominated by microbes, including billions of bacteria and meters of fungal hyphae, but also includes a vast array of larger fauna like nematodes, mites, springtails, and earthworms. These organisms form a complex and intricate food web that is the engine of terrestrial ecosystems. They are responsible for critical processes such as decomposing organic matter, recycling nutrients, fixing nitrogen from the air, improving soil structure, and suppressing plant diseases. The health of this subterranean community is directly linked to the health of the plants growing above it, influencing agricultural productivity and the stability of natural ecosystems. This incredible, unseen majority of life is the foundation upon which all life on land is built. Fact 76. The Great Barrier Reef is visible from space. The Great Barrier Reef, located off the coast of Queensland, Australia, is the world's largest coral reef system and the single largest structure made by living organisms. It is so vast that it is the only living thing visible from outer space with the naked eye. The reef system is composed of over 2,900 individual reefs and 900 islands, stretching for over 2,300 kilometers over an area of approximately 344,400 square kilometers. It was constructed over millions of years by billions of tiny coral polyps, which are soft-bodied animals related to anemones and jellyfish. These polyps secrete a hard skeleton of calcium carbonate, which over generations builds up to form the massive, complex structures of the reef. The reef supports an unparalleled diversity of life, including thousands of species of fish, hundreds of coral species, and countless mollusks, rays, dolphins, and sharks. It is a UNESCO World Heritage Site and a global icon of marine biodiversity. Fact 77. It is the largest living structure on Earth. The Great Barrier Reef holds the title of the largest living structure on Earth. This distinction is based on its sheer scale and the fact that it is built and maintained by living organisms, the coral polyps. Unlike a forest, which is a collection of individual trees, the reef is an interconnected, continuous limestone structure created by the collective skeletons of countless generations of corals. The construction of this massive ecosystem began after the last ice age, around 20,000 years ago, as sea levels rose, and has been growing and evolving ever since. The reef is not a single entity but a complex mosaic of coral types, providing a multitude of habitats. Its status as a living structure is under threat from climate change, which causes coral bleaching, where corals expel their symbiotic algae, ocean acidification, which hinders skeleton formation, and pollution. Its preservation is critical for the survival of the immense biodiversity it harbors. Fact 78. Coral reefs cover less than 1% of the ocean. Despite their immense ecological and economic importance, coral reefs occupy a surprisingly small footprint on the planet. They cover less than 1% of the entire ocean floor, an area roughly half the size of France. This tiny sliver of the seafloor, however, supports an astonishingly disproportionate amount of marine life. Coral reefs, often called the rainforests of the sea, due to their incredible biodiversity. They provide a complex three-dimensional habitat that offers food, shelter, and nursery grounds for an estimated 25% of all marine species. This includes over 4,000 species of fish, 800 species of hard corals, and thousands of other plants and animals. This high density of life in such a small area makes reefs critically important for global marine biodiversity. Their limited area also makes them highly vulnerable to localized threats like pollution, overfishing, and physical damage, as well as global threats like ocean warming and acidification. Fact 79. They contain 25% of all marine species. The statistic that coral reefs support 25% of all known marine species is a powerful testament to their role as biodiversity hotspots. Although they occupy less than 1% of the ocean floor, the complex architecture of a healthy reef provides an immense variety of microhabitats, nooks, crannies, ledges, and caves that are exploited by a vast array of organisms. This includes a huge diversity of fish, invertebrates like crabs, shrimp, and sea urchins, mollusks, sea turtles, and sharks. The reef structure itself is built by the corals, which are animals, and is often covered in coralline algae and sponges. This concentration of life makes reefs vital for the health of the wider ocean, as they act as spawning and nursery grounds for many species that spend their adult lives in other habitats. This incredible biodiversity also provides essential services to humans, including fisheries that feed millions, opportunities for tourism, and a potential source for new medicines. Fact 80. The coldest temperature was -89.2 degrees Celsius in Antarctica. The lowest natural temperature ever directly recorded on the Earth's surface was -89.2 degrees Celsius -128.6 degrees Fahrenheit at the Soviet Vostok Station in Antarctica on July 21, 1983. Vostok is located on the high polar plateau, which sits at an elevation of about 3,500 meters, and is one of the most isolated and inhospitable places on the planet. This extreme cold occurs during the polar winter when there is no sunlight for months, and the clear, dry air allows heat to radiate freely out into space. Satellite data has since suggested that ridges on the East Antarctic Plateau can get even colder, with temperatures potentially dipping below -92 degrees Celsius -134 degrees Fahrenheit in shallow hollows where cold, dense air can pool. At these temperatures, the air itself feels thick, and metals can become brittle. Ordinary activities become life-threatening challenges, as exposed skin would freeze in seconds, and carbon dioxide in the atmosphere can condense into dry ice snow. Fact 81. The hottest temperature was 56.7 degrees Celsius in Death Valley. The highest air temperature ever reliably recorded on Earth was 56.7 degrees Celsius (134.1 degrees Fahrenheit) at Furnace Creek Ranch in Death Valley, California, USA, on July 10, 1913. Death Valley is a long, narrow basin that lies 86 meters below sea level, surrounded by high, steep mountain ranges. This geography is key to its extreme heat. The clear, dry air allows intense sunlight to heat the desert surface, and the trapped heat radiates back from the rocky floor, but it is prevented from escaping by the high valley walls. The air sinks and warms adiabatically as it circulates, creating a massive natural oven. This official record has been scrutinized but is accepted by the World Meteorological Organization. In recent years, temperatures have come close to this record, with 54.4 degrees Celsius (130 degrees Fahrenheit) recorded in both 2020 and 2021. These extreme conditions make Death Valley a living laboratory for studying the limits of life and the effects of intense heat on the environment. Fact 82. The windiest place is Commonwealth Bay, Antarctica. Commonwealth Bay in Antarctica is recognized by the Guinness World Records and the World Meteorological Organization as the windiest place on Earth. Katabatic winds here regularly exceed 240 kilometers per hour, 150 miles per hour. These winds are not storms, but a near-constant, relentless flow. They are created by cold, dense air accumulating over the high, frigid polar plateau of Antarctica. This air, being heavier, flows downhill under the force of gravity, accelerating to tremendous speeds as it funnels through steep valleys and glacier, like the massive Denman Glacier, which empties into Commonwealth Bay. The wind is so persistent and powerful that it keeps the bay largely free of sea ice, creating an area known as a polynya. The explorer Sir Douglas Mawson, who built a base there in 1912, called it the home of the blizzard, and his team endured these horrific winds for an entire year, describing the experience as one of the most brutal ordeals in the history of Antarctic exploration. Fact 83. The driest place is the Atacama Desert. The Atacama Desert in Chile is the driest non-polar place on Earth. Some weather stations in the Atacama have never recorded a single drop of rain, and the average annual precipitation is less than 1 millimeter. Its extreme aridity is caused by a perfect storm of geographical factors. It is located in a double rain shadow. The prevailing southeast trade winds are blocked by the Andes Mountains to the east, and the cold Humboldt Current in the Pacific Ocean to the west chills the air, minimizing evaporation and cloud formation. The soil is so desiccated and lifeless that it is often used as an analog for the Martian surface, and NASA tests its Mars rovers there. Despite this, life persists in specialized forms, such as microbes in the salt crusts and flowering plants that bloom spectacularly in rare years when El Niño brings a trace of moisture. The desert's clear, dry air also makes it one of the best places on Earth for astronomical observation. Fact 84. It has parts where rain has never been recorded. Within the hyperarid core of the Atacama Desert, there are specific regions where rainfall has never been instrumentally recorded by humans. This includes areas around the Yungay district and parts of the Central Depression. Scientists studying the soil chemistry and geology in these areas believe that some parts may not have seen significant rainfall for over 400 years, and possibly as long as 2 to 3 million years. The evidence comes from extremely thick salt deposits, nitrates, that could only form over immense timescales without being washed away. The landscape is so dry that it lacks the typical features of erosion caused by water. Instead, the terrain is shaped by wind and the occasional flow of water from melting snow high in the Andes, which never reaches the desert core. This makes the Atacama's core the closest terrestrial equivalent to the absolute dryness of Mars and a critical site for understanding the absolute limits of life. Fact 85. The wettest place is Mawsynram, India. The village of Mawsynram in the Indian state of Meghalaya holds the world record for the highest average annual rainfall. It receives a staggering average of 11,871 millimeters, 467 inches, of rain per year. This extreme precipitation is a result of its unique geographical location. Mawsynram is situated on the southern slopes of the Khasi Hills, directly in the path of the moisture-laden summer monsoons blowing in from the Bay of Bengal. As the warm, wet air hits the steep slopes, it is forced to rise rapidly. This ascent causes the air to cool, condense, and release its immense load of water in the form of torrential, near-continuous rain during the monsoon season. The local culture has adapted ingeniously to this environment, with the Khasi people creating living root bridges by training the roots of rubber trees across rivers, which grow stronger over centuries and can withstand the powerful floods that would wash away conventional bridges. Fact 86. Lightning strikes the Earth 100 times per second. Lightning is a constant and dramatic feature of our planet's atmosphere. On a global scale, it is estimated that lightning strikes the ground somewhere on Earth approximately 100 times every single second. This equates to about 8.6 million strikes per day and over 3 billion strikes per year. The majority of these strikes occur over land rather than ocean, as the sun heats the continents more quickly, creating stronger updrafts necessary for thunderstorm development. The hotspots for lightning activity are Central Africa, the Himalayas, and South America. These discharges are not just spectacular light shows, they play a crucial role in the Earth's nitrogen cycle. The immense heat of a lightning bolt causes nitrogen and oxygen in the air to combine, forming nitrogen oxides that dissolve in rain and fall to the ground as natural fertilizer, nourishing plants. This constant electrical activity is a powerful reminder of the dynamic and energetic nature of our planet's weather systems. Fact 87. A single bolt can heat the air to 30,000 degrees Celsius. A lightning bolt is a channel of electrical energy of immense power. The electrical resistance of the air it travels through causes the air to be heated instantaneously to an astonishing temperature of around 30,000 degrees Celsius. This is about 5 times hotter than the surface of the sun. This rapid, superheating of the air causes it to expand explosively, creating a shock wave that we hear as thunder. The initial lightning channel is only a few centimeters wide, but it carries a current of 30,000 to 300,000 amperes. The duration of a typical stroke is incredibly short, only about 30 microseconds, but the energy released is massive. This extreme heat is also responsible for other phenomena associated with lightning, such as fulgurites, glass tubes formed when lightning melts and fuses sand or rock on the ground. The sheer energy contained in a single bolt underscores the violent and powerful forces at work within a common thunderstorm. Fact 88. There are about 500,000 detectable earthquakes. The United States Geological Survey estimates that several million earthquakes occur in the world each year. The vast majority are too small or too deep to be felt. However, thanks to modern sensitive seismographs, we are able to detect about 500,000 earthquakes annually. This number includes all events large enough to be located by seismic networks. Of these 500,000 detectable quakes, about 100,000 are strong enough to be felt by people near the epicenter. Only about 100 per year are actually large enough to cause damage if they occur near populated areas. The frequency of earthquakes follows a predictable pattern known as the Gutenberg-Richter law, which states that for each unit increase in magnitude, there are about 10 times fewer earthquakes. So, while there are hundreds of thousands of tiny magnitude 2 to 3 quakes, there is, on average, only one great earthquake of magnitude 8 or higher per year. This constant seismic activity is a reminder that the Earth's tectonic plates are in continuous motion. Fact 89. Most are too small to be felt. Of the approximately 500,000 earthquakes detected by seismographs each year, the overwhelming majority are of very low magnitude. It is estimated that about 90 to 95% of these quakes register at a magnitude of 2.5 or less. At this intensity, the seismic waves are so weak that they are imperceptible to humans. They are often referred to as microquakes. The energy released in these tiny tremors is equivalent to less than a gallon of gasoline exploding. They are typically only recorded by sensitive instruments and are crucial for scientists mapping fault lines and understanding subsurface geology. The fact that most tectonic activity manifests as these minor, harmless releases of energy is a testament to the fact that the Earth's crust is constantly, and usually gently, adjusting to stress. It is only when stress builds up and is released in a larger, less frequent rupture that we get the damaging earthquakes that make headlines. Fact 90. About 100,000 earthquakes are felt each year. While hundreds of thousands of earthquakes occur annually, only a fraction, approximately 100,000, are strong enough to be felt by people. These are typically earthquakes of magnitude 2.5 or greater, which is the threshold at which sensitive individuals, especially on upper floors of buildings, might notice a slight shaking or vibration. As the magnitude increases, the area over which the quake can be felt expands dramatically. A magnitude 3.0 quake might be felt by a few people near the epicenter, while a magnitude 5.0 can be felt across a small region and may cause minor damage. The number of felt earthquakes is not evenly distributed. They are concentrated along the tectonic plate boundaries, such as the Pacific Ring of Fire. This statistic highlights that while the Earth is constantly trembling, most of its movements are either too small for us to notice or occur in remote, unpopulated areas like the deep ocean floor. Fact 91. A magnitude 9.5 is the strongest recorded. The most powerful earthquake ever recorded by seismographs was the 1960 Valdivia earthquake in Chile, which registered a staggering magnitude of 9.5. Striking on May 22, 1960, the quake ruptured a fault zone nearly 1,000 kilometers long. The energy released was so immense that it is estimated to be equivalent to over 20,000 Hiroshima-type atomic bombs. The shaking lasted for approximately 10 minutes and generated a devastating Pacific-wide tsunami. Waves as high as 25 meters ravaged the Chilean coast, while tsunamis traveled across the ocean, causing significant damage and fatalities in Hawaii, Japan, the Philippines, and the west coast of the United States. The event even led to the eruption of the Cordon Col volcano in Chile 2 days later. The Valdivia earthquake fundamentally changed our understanding of the power of subduction zones and led to the establishment of the worldwide standardized seismograph network and the Pacific Tsunami Warning System, highlighting how a single geological event can have global consequences and drive international scientific cooperation. Fact 92. Earth has a hum caused by ocean waves. Our planet constantly emits a low-frequency, inaudible vibrational signal known as the Earth's hum. This persistent hum, with frequencies between 2.7 and 4.5 MHz, is far below the range of human hearing. For decades, its source was a mystery, but research has now confirmed that the primary cause is the interaction of ocean waves with the seafloor. There are two main mechanisms. The first is the pressure of giant storm-driven waves on the seafloor, which acts like a finger constantly tapping the planet. The second, more significant mechanism involves the collision of opposing ocean swells from different storms, which creates a steady, fluctuating pressure on the seabed. This energy is then transferred into the solid Earth, causing it to resonate like a giant bell. The hum is present even during seismically quiet periods and can be detected by sensitive seismometers worldwide. Studying this hum helps scientists create detailed images of the Earth's deep interior structure, as the waves penetrate all the way to the core. Fact 93. The sky is blue because of Rayleigh scattering. The blue color of the clear daytime sky is a result of a phenomenon called Rayleigh scattering. Sunlight, which appears white, is actually composed of a spectrum of colors, each with a different wavelength. As sunlight travels through the Earth's atmosphere, it collides with gas molecules and tiny particles. These collisions cause the light to be scattered in different directions. Rayleigh scattering is much more effective for shorter wavelengths of light, the blues and violets, than for longer wavelengths like red and orange. Therefore, the blue light is scattered across the sky in all directions, essentially filling the dome of the sky with blue light for our eyes to see. The violet light is scattered even more, but our eyes are less sensitive to violet, and some of it is absorbed by the upper atmosphere, which is why we perceive the sky as blue rather than violet. When we look towards the sun at sunset, we see the longer, red wavelengths that were not scattered away, which is why sunsets appear red and orange. Fact 94. Sunsets are red for the same reason. The spectacular red and orange colors of a sunset are a direct consequence of the same Rayleigh scattering that makes the sky blue. During sunrise and sunset, the sun is positioned low on the horizon. This means its light must travel through a much thicker portion of the Earth's atmosphere to reach our eyes compared to when it is directly overhead. This longer journey gives the atmosphere more opportunity to scatter the shorter wavelength blue and violet light out of the line of sight. The light that finally reaches us is predominantly the longer wavelengths, red, orange, and yellow, which are scattered less effectively. This process is enhanced when there are additional particles in the atmosphere, such as dust, pollution, or ash from a volcanic eruption, which can scatter even more blue light and lead to exceptionally vivid and deep red sunsets. Thus, the beauty of a sunset is a dramatic demonstration of the physics of light interacting with our planet's protective blanket of air. Fact 95. The ocean is blue because water absorbs colors. While the sky's blue color influences the ocean's appearance, the primary reason for the ocean's blue hue is the absorption and scattering of light by the water molecules themselves. Water absorbs light in the red part of the spectrum much more efficiently than light in the blue part. When sunlight enters the water, the red, orange, yellow, and green wavelengths are absorbed by the water molecules, while the blue wavelengths are scattered and reflected back to our eyes. This is the same reason a swimming pool looks blue. In very clear, deep water, this effect is most pronounced, resulting in a deep, vivid blue. In shallower, coastal areas, the water may appear greener. This is due to the presence of sediments and phytoplankton, which contain pigments, like chlorophyll, that absorb light in the blue and red spectra and reflect green. The color of the ocean is therefore a complex indicator of its depth, purity, and biological activity. Fact 96. Some beaches have green or black sand. While most beaches feature tan or golden sand from quartz and feldspar, some beaches boast more exotic colors due to unique local geology. Green sand beaches, such as Papacolia Beach in Hawaii, are exceptionally rare. Their color comes from the mineral olivine, also known as peridot, a green silicate mineral that crystallizes from volcanic magma. The olivine erodes out of surrounding volcanic cinder cones and accumulates on the beach, outlasting other minerals. Black sand beaches are more common and are formed from volcanic activity. They are composed of fine grains of dark, basaltic lava and volcanic glass, created when hot lava flows into the ocean and shatters upon contact with the cold water. Famous examples include Punaluu Beach in Hawaii and Reynisfjara in Iceland. These striking beaches are dramatic reminders of the powerful volcanic forces that shape our planet, but the sand can become dangerously hot in the sun due to its dark color. Fact 97. There are pink lakes in Australia and Senegal. Several lakes around the world, most famously Lake Hillier in Australia and Lake Retba in Senegal, display a stunning and persistent pink color. This bizarre hue is not an optical illusion or a trick of the light. The water is genuinely pink. The cause is a combination of high salinity and the presence of a specific type of halophilic, salt-loving, microalgae, primarily Dunaliella salina and pink halobacteria. These organisms produce red pigments, specifically beta-carotene, as a protective mechanism against the intense solar radiation in the shallow, salty waters. The high salt concentration, often higher than that of the Dead Sea, allows these organisms to thrive and concentrate their pigment, tinting the entire body of water. In Lake Retba, the color is most vibrant during the dry season. The lakes are safe to swim in, though the extreme salinity makes it easy to float, and the salt can be harvested, which is a major local industry in Senegal. Fact 98. The Earth glows from air glow and light pollution. When viewed from space at night, the Earth is not completely dark. It is adorned with two distinct types of light. The most obvious is the artificial glow of human civilization, the sprawling networks of city lights that trace the outlines of continents and coastlines. This is light pollution, a marker of our urbanized world. However, even in the darkest, most remote regions, a faint, natural glow emanates from the atmosphere itself. This phenomenon is called air glow. It is caused by various chemical reactions in the upper atmosphere, primarily involving oxygen and nitrogen atoms that were broken apart by solar ultraviolet radiation during the day. At night, these atoms recombine, releasing energy in the form of a soft, multicolored light. Air glow is different from the aurora, as it is generated by continuous chemical processes rather than solar particles channeled by magnetic fields. This natural veil of light is a constant, planet-wide phenomenon that highlights the dynamic nature of our atmosphere. Fact 99. Auroras are caused by solar particles. Auroras, the mesmerizing curtains of light in polar skies, are a direct result of the interaction between our planet and the Sun. The Sun constantly emits a stream of charged particles called the solar wind. When these particles, mostly electrons and protons, approach Earth, they are guided by our planet's magnetic field toward the polar regions. There, they collide with atoms and molecules in the upper atmosphere, primarily oxygen and nitrogen. These collisions transfer energy to the atmospheric gases, exciting their electrons. When the electrons return to their normal state, they release this energy in the form of light, a process similar to what happens in a neon sign. The color of the aurora depends on which gas is hit and at what altitude: green and red from oxygen, and pink and purple from nitrogen. The intensity of auroral displays is closely tied to solar activity, such as solar flares and coronal mass ejections, which can supercharge the solar wind and create spectacular, widespread geomagnetic storms. Fact 100. The southern aurora is called aurora australis. The spectacular light show seen in the southern hemisphere is known as the aurora australis, or the southern lights. It is the direct southern counterpart to the aurora borealis, northern lights, and is created by the exact same physical process: charged particles from the solar wind being funneled by Earth's magnetic field and colliding with atmospheric gases, causing them to glow. While the phenomenon is identical, the aurora australis is generally less observed and famous simply because there is far less landmass at the high southern latitudes where it is most visible. The best land-based viewing locations are in Antarctica, southern Chile and Argentina, New Zealand, Tasmania, and the Falkland Islands. Like its northern sibling, the aurora australis can display a dazzling array of colors, including vibrant greens, pinks, and purples, dancing and shimmering across the sky. It serves as a brilliant reminder that Earth's magnetic field creates two symmetrical theaters for this cosmic display. Fact 101. The northern aurora is called aurora borealis. The celestial display of light in the northern hemisphere is famously known as the aurora borealis, or the northern lights. The name was coined by the scientist Galileo Galilei in 1619, after the Roman goddess of the dawn, Aurora, and the Greek name for the north wind, Boreas. This phenomenon occurs when charged particles from the Sun, carried by the solar wind, are funneled down Earth's magnetic field lines and collide with gas molecules in the upper atmosphere, between 100 and 400 kilometers in altitude. These collisions excite the atoms, causing them to emit photons of light. The most common color, a brilliant green, is produced by oxygen molecules at lower altitudes. Red auroras are rarer and come from high-altitude oxygen, while nitrogen produces blue and purple hues. The aurora borealis is most frequently visible in a ring-shaped zone called the auroral oval, centered over the magnetic North Pole, making regions like Scandinavia, Alaska, Canada, and Iceland prime viewing locations, especially during periods of high solar activity. Fact 102. They can be seen from space. Auroras are not just an earthbound spectacle, they are a planetary-scale phenomenon best appreciated from orbit. Astronauts aboard the International Space Station, ISS, have a unique, front-row seat to these dazzling light shows. From their vantage point, they can look down directly onto the shimmering curtains of the aurora as they dance across the high-latitude regions. The view from above is profoundly different. Instead of looking up at ribbons of light, astronauts see the aurora as a thin, glowing layer clinging to the Earth's limb, often with the stars shining brilliantly above it. The ISS sometimes even flies directly through the fringes of the auroral particles. Satellites equipped with specialized cameras also capture stunning global views of the entire auroral oval simultaneously, providing scientists with invaluable data on the dynamics of this complex interaction between the Sun's energy and Earth's magnetic field and atmosphere. Fact 103. There are crystals larger than cars in Mexico. Deep within the Naka mine in Chihuahua, Mexico, lies a breathtaking geological wonder, the Cave of the Crystals. This chamber contains some of the largest natural crystals ever found on Earth, with translucent gypsum, selenite, beams reaching over 11 meters in length and weighing up to 55 tons. These colossal crystals formed over hundreds of thousands of years under very unique and extreme conditions. The cave was filled with mineral-rich water that was heated by magma below and maintained at a very stable, scorching temperature of around 58 degrees Celsius. This stable, hot environment allowed the minerals to dissolve and precipitate out of the solution very slowly, enabling the crystals to grow to their mammoth proportions. The cave was only discovered in 2000 when miners pumped the water out. It is uninhabitable for humans without specialized cooling suits, as the extreme heat and humidity can be lethal within minutes, preserving this otherworldly landscape in its pristine state. Fact 104. The largest cave is Sun Doong in Vietnam. Sun Doong Cave in Phong Nha Cơ Bang National Park, Vietnam, is the world's largest known natural cave by volume. Discovered in 1991 and first explored in 2009, its mind-boggling scale is difficult to comprehend. The cave is over 5 kilometers long, with sections where the ceiling collapses, creating massive sinkholes known as dolins. These openings allow sunlight to pour in, fostering the growth of entire, isolated jungles within the cave, a phenomenon so unique the areas are called Edens. The main passage is so vast it could accommodate a 40-story skyscraper and is large enough to house a city block with room to spare. It contains its own fast-flowing subterranean river, ancient fossilized stalagmites, and cave pearls the size of baseballs. Sun Doong is a pristine and fragile ecosystem, home to unique species of fish, insects, and birds, and represents one of the most spectacular and recent discoveries in the world of speleology. Fact 105. It has its own jungle and weather system. The immense size of Sun Doong Cave allows for the development of its own localized and isolated ecosystems and weather. Where the limestone ceiling has collapsed, two enormous dolins have opened to the sky above. Sunlight streams through these openings, enabling dense, lush jungles to thrive on the cave floor hundreds of meters below the surface. Explorers have named these areas the Garden of Edam and the Watch Out for Dinosaurs Doline. The contrast between the humid jungle air and the cooler cave air, combined with moisture from the underground river, leads to the formation of clouds and mist inside the cavernous passages. On many days, a thick, ethereal fog forms and lingers beneath the cave ceiling, creating a self-contained weather system within the mountain. This creates a surreal, otherworldly landscape where one can walk through a cloud-filled cavern, surrounded by jungle, deep inside the earth. Fact 106. The deepest cave is Veryovkina in Georgia. The Veryovkina Cave, located in the Arabica Massif of the Western Caucasus in Abkhazia, Georgia, is the deepest known cave on Earth. After decades of exploration by dedicated cavers, its recorded depth reached a staggering 2,212 meters in 2018. To put this in perspective, it is more than 6 times the height of the Eiffel Tower. Reaching the bottom is a monumental expedition that takes weeks, involving rappelling down vertical pits, navigating treacherous, water-filled passages, and camping in the cold, dark chambers along the way. The cave is a super deep cave, characterized by its vertical, pit-like structure. The lowest chamber, named the last camp, was found to be flooded with water, preventing further descent. Exploration of such extreme environments is as challenging as high-altitude mountaineering, requiring immense technical skill, endurance, and psychological fortitude to navigate the absolute darkness and isolation. Fact 107. It is over 2.2 kilometers deep. The depth of Veryovkina Cave, exceeding 2.2 kilometers, means that its lowest point lies more than 2 kilometers below the entrance. At such depths, the environment is one of the most extreme on the planet. Cavers are completely isolated from the surface world, facing constant, near-freezing temperatures and 100% humidity. The air pressure is higher, and the air can become stagnant or contain dangerous levels of gases. There is no natural light whatsoever. The world exists only within the beam of a headlamp. The journey to the bottom is a multi-day, technically demanding vertical climb through a labyrinth of shafts and narrow passages, often requiring diving through submerged sections known as sumps. The discovery and mapping of these super-deep caves are testament to human exploration and perseverance, pushing the boundaries of what we know about the subterranean world and revealing new geological formations and unique, specialized life forms adapted to total darkness. Fact 108. The longest cave system is Mammoth Cave. Mammoth Cave National Park in Kentucky, USA, is home to the world's longest known cave system. As of 2024, more than 685 kilometers of surveyed passageways have been mapped, and explorers believe there are hundreds more miles yet to be discovered. The cave system is a labyrinthine network of vast chambers, long, winding tunnels, and deep vertical shafts formed in a thick layer of limestone. Its formation began millions of years ago as slightly acidic groundwater dissolved the soluble bedrock, creating the passages. The cave is renowned for its diversity of geological features, including spectacular stalactites, stalagmites, and flowstone formations, as well as its unique history, which includes use by Native Americans thousands of years ago and later as a saltpeter mine during the War of 1812. The ecosystem within the cave is fragile and hosts a variety of specialized, troglodytic species, such as the eyeless Kentucky cave shrimp and the colorless mammoth cave spider. Fact 109. It is over 685 kilometers long. The sheer length of the Mammoth Cave system, over 685 kilometers and growing with each new expedition, is difficult to visualize. This distance is longer than the drive from New York City to Cleveland, Ohio. The cave is not a single, linear tunnel but an immense, interconnected, and complex maze on multiple levels. The passages were formed by different rivers at different times, creating a multi-story geological structure. Mapping this sprawling underground network is a continuous effort conducted by volunteer cavers who meticulously survey new passages, often crawling through tight, muddy squeezes to discover new rooms and connecting tunnels. The total extent of the system is unknown because many passages are blocked by breakdowns or flooded with water. This vast underground wilderness represents one of the most significant natural wonders on the planet and provides an invaluable record of geological history and a unique laboratory for studying subterranean biology. Fact 110. There are more trees on Earth than stars. A groundbreaking 2015 study published in the journal Nature estimated that there are approximately 3.04 trillion trees on our planet. This staggering number far exceeds the estimated number of stars in our home galaxy, the Milky Way, which is between 100 and 400 billion. This means there are roughly 8 to 30 trees for every single star in our galaxy. The study combined satellite imagery with ground-based forest surveys from over 1 million locations around the world to arrive at this figure, which is nearly 8 times higher than previous estimates. However, the research also delivered a sobering message. Compared to the dawn of human civilization, the global number of trees has fallen by nearly 46%. We are currently cutting down about 15 billion trees every year while only regaining around 5 billion, highlighting the profound impact humanity has had on the planet's forest ecosystems despite their still immense scale. Fact 111. There are trillions of trees on the planet. The figure of 3 trillion trees on Earth is a testament to the planet's verdant nature, but it also reveals a complex and concerning story. This number, established by a comprehensive Yale University study, is not evenly distributed. The highest tree densities are found in the boreal forests of Russia, Scandinavia, and North America, and the tropical rainforests of the Amazon, Congo, and Southeast Asia. These forests are critical carbon sinks, absorbing billions of tons of carbon dioxide from the atmosphere each year. However, the study also provided a historical context, estimating that since the advent of agriculture and civilization around 11,000 years ago, the total number of trees has been slashed by nearly half. This ongoing deforestation, driven by agricultural expansion, logging, and urban development, has a double impact. It removes carbon-absorbing trees and often releases stored carbon back into the atmosphere, accelerating climate change and causing irreversible biodiversity loss. Fact 112. There are more viruses than stars. The abundance of viruses on Earth is almost incomprehensibly vast. It is estimated that there are about 10 nonillion, that's a 1 followed by 31 zeros, individual viral particles on the planet. This number is not just greater than the number of stars in the Milky Way, it is greater than the number of stars in the entire observable universe, which is estimated to be around 10 sextillion, a 1 followed by 23 zeros. Viruses are the most numerous biological entities on Earth, found in every ecosystem, from the highest atmosphere to the deepest ocean trenches and deep within the Earth's crust. The vast majority are bacteriophages, which infect bacteria, and they play a crucial role in regulating microbial populations and driving evolution through gene transfer. This virusphere represents a massive, largely unexplored reservoir of genetic diversity that profoundly influences global biochemical cycles and the health of all living organisms. Fact 113. Microbes make up most of Earth's biomass. When measuring the total mass of all living organisms on Earth, the global biomass, plants dominate, constituting about 82% of the total. However, if we look at the composition of life in terms of the number of different types of organisms, the world belongs to microbes. Bacteria, archaea, fungi, and protists represent the overwhelming majority of Earth's genetic diversity. In terms of carbon content, all animals combined, including every human, insect, fish, and elephant, make up only about 0.4% of the global biomass. In contrast, bacteria alone account for about 13%, and fungi for another 2%. This microscopic majority is the foundation of the biosphere, driving the planet's essential nutrient cycles, such as the carbon and nitrogen cycles. They are in the soil, water, and air, and even inside our own bodies, performing functions without which complex life could not exist. Fact 114. Humans are a tiny fraction of life. Despite our profound impact on the planet, humans constitute an almost negligible portion of Earth's total biomass. In terms of carbon content, the roughly 8 billion humans on Earth represent only about 0.01% of the global total. To put this in perspective, the biomass of tiny arthropods like krill is nearly double that of humanity, and the biomass of earthworms is roughly equal to ours. The biomass of all wild mammals is only a fraction of our own, highlighting how domestication has shifted the balance. The combined weight of our livestock, primarily cattle and pigs, is far greater than that of all wild mammals. This statistic powerfully illustrates that our influence on the planet's ecosystems, climate, and geology is not a function of our physical mass, but of our technological capabilities and collective behavior, which have allowed us to reshape the world far beyond our numerical or physical proportion. Fact 115. The world's largest organism is a fungus. In the Mulhern National Forest in Oregon, USA, lives the largest known organism on Earth by area, a honey fungus, Armillaria ostoi*, nicknamed the humongous fungus. This single fungal individual spans an astonishing 2,385 acres, nearly 10 square kilometers. It is estimated to be between 2,000 and 8,000 years old. The organism mostly lives underground as a massive network of black, shoestring-like filaments called rhizomorphs, which spread out in search of new tree roots to colonize. Above ground, it produces clusters of honey-colored mushrooms. Scientists confirmed it was a single individual by taking genetic samples from across the vast area. This fungus is a pathogenic parasite, slowly killing the conifer trees in its path. Its immense size and age challenge our traditional perception of an individual and showcase the incredible, often unseen, power of the fungal kingdom. Fact 116. It covers 2,385 acres in Oregon, USA. The sheer scale of the humongous fungus in Oregon is difficult to grasp. Covering 2,385 acres, It is larger than the size of the Paris urban area and more than 3 times the size of Central Park in New York City. This single, interconnected organism grows primarily underground, and its spread is a slow but relentless process. The fungus grows through the soil and forest litter, sending out rhizomorphs that invade the roots of trees, draining them of water and nutrients. This eventually kills the tree, and the fungus then consumes the dead wood. While it is a destructive force in the forest, it is also a vital agent of decomposition and ecological renewal. The discovery of this fungal giant has led to the identification of other massive *Armillaria* individuals around the world. But the Oregon specimen remains the champion, a testament to the hidden, interconnected, and enduring nature of life. Fact 117. The oldest living organism is a seagrass clone. The title for the oldest known living individual organism belongs to a seagrass, *Posidonia oceanica*, located in the Mediterranean Sea near the island of Ibiza. Genetic analysis has revealed that a single clonal colony of this seagrass spans up to 15 kilometers of seabed and is estimated to be between 80,000 and 200,000 years old. This means it began its life during the last ice age. Clonal organisms grow by replicating their genetic material and spreading horizontally, creating new shoots and roots that are genetically identical. While individual shoots may only live for a few decades, the entire genetic individual persists for millennia. This seagrass meadow has survived countless climate shifts and sea level changes by slowly expanding across the ocean floor. Its immense age provides a unique, continuous biological record of the Mediterranean's environmental history, but it is now threatened by modern pressures like climate change, pollution, and boat anchors. Fact 118. It is over 200,000 years old. An age of 200,000 years places the ancient Mediterranean seagrass clone's origin in a world vastly different from our own. It began its life during a glacial period when sea levels were over 100 meters lower than today, and Neanderthals still walked the Earth. Its survival through multiple glacial and interglacial cycles is a remarkable feat. The key to its longevity is its clonal growth strategy. Rather than relying on risky sexual reproduction, it expands vegetatively through its rhizomes, creating genetically identical offspring. This allows it to persist in a stable, favorable environment for an immense duration. However, this same strategy of slow, steady growth makes it highly vulnerable to rapid environmental change. The recent, accelerated warming of the Mediterranean and human-induced damage now pose a significant threat to an organism that has weathered hundreds of millennia of natural change, highlighting the unprecedented impact of modern human activity. Fact 119. Tardigrades can survive in space. Tardigrades, also known as water bears or moss piglets, are microscopic, 8-legged animals renowned as the toughest creatures on Earth. In 2007, they became the first known animal to survive exposure to the vacuum and radiation of outer space. During a European Space Agency mission, tardigrades were placed outside a spacecraft in low Earth orbit. After 10 days, many were successfully revived upon rehydration. They can withstand these extreme conditions by entering a state called cryptobiosis, a form of suspended animation where they curl into a ton, expel almost all of their body water, and dramatically slow their metabolism to an undetectable level. In this state, they can endure temperatures from just above absolute zero to well above the boiling point of water, pressures 6 times greater than those in the deepest ocean trenches, and doses of radiation that would be lethal to almost any other life form. Fact 120. They are known as water bears. The nickname water bear comes from their lumbering, bear-like gait when they walk under microscope. These resilient microanimals are typically about 0.5 millimeters long and are found in some of the most diverse and extreme environments on Earth, from the deep sea and Himalayan mountaintops to tropical rainforests and the Antarctic dry valleys. They are not extremophiles in the sense that they prefer these conditions. They are extremotolerant, meaning they can endure them by shutting down their metabolism. Their ability to survive in space has made them a central focus in the field of astrobiology, as they provide a model for considering the potential for life to be transported between planets, a theory called panspermia, and the limits of life's tenacity. Their unique biology continues to inspire research in fields as diverse as medicine and materials science. Fact 121. Some bacteria can eat radioactive waste. In a remarkable display of microbial adaptability, certain species of bacteria have evolved mechanisms to survive in and even process radioactive environments. One of the most studied is Geobacter sulfurdidans star. This bacterium does not eat radiation itself, but it can interact with radioactive materials in a way that renders them less dangerous. Geobacter species are known for their ability to respire using metals instead of oxygen, a process called bioremediation. They can convert soluble radioactive metals, such as uranium, uranium-238, and plutonium, from a soluble, mobile form that can contaminate water supplies into an insoluble, solid form. This solid form precipitates out of the water, effectively immobilizing the radioactive material and preventing it from spreading through the ecosystem. Scientists are actively researching how to harness these bacteria to clean up contaminated sites, such as old nuclear weapons production facilities and nuclear power plant accidents, offering a potential natural and cost-effective solution to a persistent environmental problem. Fact 122. Life can survive without oxygen or sunlight. For most of life's history on Earth, the planet lacked oxygen, and life thrived in its absence. Today, entire ecosystems exist completely independent of both sunlight and oxygen, challenging our definition of a habitable world. The most famous examples are the deep-sea hydrothermal vent ecosystems. Here, the base of the food web is not photosynthesis, but chemosynthesis. Specialized bacteria and archaea harness chemical energy from the minerals and gases, such as hydrogen sulfide and methane, that spew from the vents. These chemosynthetic microbes then support a diverse community of complex life, including giant tubeworms, clams, shrimp, and crabs. Similar ecosystems exist in deep caves, within aquifers, and deep underground, all powered by chemical energy from the Earth's interior. Fact 123. Chemosynthesis powers deep-sea ecosystems. Chemosynthesis is the biological process that forms the foundation of life in the eternal darkness of the deep ocean. Unlike photosynthesis, which uses light energy, chemosynthesis uses the energy stored in chemical bonds to produce organic matter. The general formula involves combining carbon dioxide with hydrogen sulfide or methane, which is abundant at hydrothermal vents and cold seeps, to create sugars and other carbohydrates. For example, at a hydrothermal vent, bacteria might use the reaction CO plus O plus 4HSCHO plus 4S plus 3HO. These bacteria either live freely in the water or form symbiotic relationships with larger organisms. The giant tubeworms at vents, for instance, have no mouth or gut. They house billions of these bacteria in a specialized organ called a trophisome. The bacteria provide the worm with all its nutrients, while the worm provides the bacteria with a safe habitat and the necessary chemicals from the vent fluid. This process creates a self-sustaining oasis of life in the abyss. Fact 124. The Earth has 5 major mass extinctions. The history of life on Earth is marked by 5 major mass extinction events, where a significant percentage of all species died out in a relatively short geological time period. These big 5 are the Ordovician-Silurian extinction, 444 million years ago, the late Devonian extinction, 375 million years ago, the Permian-Triassic extinction, 252 million years ago, the most severe, wiping out 96% of marine species, the Triassic-Jurassic extinction, 201 million years ago, and the Cretaceous-Paleogene extinction, 66 million years ago, which ended the reign of the dinosaurs. Each event had different causes, often involving a combination of massive volcanic activity, climate change, sea level fluctuations, and in the case of the KPG event, a catastrophic asteroid impact. These extinctions were not just endpoints, they were also pivotal turning points that cleared ecological niches and paved the way for the rapid evolution and diversification of surviving lineages, including, eventually, mammals and humans. Fact 125. We are likely in the 6th mass extinction. Many scientists argue that Earth is currently undergoing a 6th mass extinction, driven not by natural disasters but by human activity. This Anthropocene extinction is characterized by a dramatically accelerated rate of species loss, estimated to be 100 to 1,000 times higher than the natural background rate. The primary drivers are habitat destruction, deforestation, urbanization, overexploitation, hunting, fishing, pollution, the spread of invasive species, and human-induced climate change. Unlike past extinctions, which unfolded over thousands or millions of years, this one is happening over centuries. The current rate of vertebrate species loss mirrors the patterns that preceded the previous 5 mass extinctions. This event is unique because it is caused by a single species and, theoretically, could be mitigated by changes in human behavior, policy, and global conservation efforts, making the preservation of biodiversity one of the most urgent challenges of our time. Fact 126. The magnetic field is weakening in one area. Earth's magnetic field is not uniform, and one of its most significant and puzzling features is a large region of weakness known as the South Atlantic Anomaly, SAA. Stretching from South America to Southwest Africa, the magnetic field strength in this area is about 30% weaker than in other regions at similar latitudes. This weakness is not static. It has been growing in size, and the field strength has been decreasing for at least the last 160 years. The leading scientific theory suggests it is caused by a vast reservoir of dense rock called the African Large Low Shear Velocity Province, located at the core mantle boundary beneath Africa. This structure may be disrupting the flow of molten iron in the outer core, thereby damping the magnetic field generation process in that region. The SAA is a clear indicator that the geodynamo is a complex and dynamic system, and its behavior provides crucial clues about the workings of Earth's deep interior. Fact 127. This area is called the South Atlantic Anomaly. The South Atlantic Anomaly, SAA, is more than just a scientific curiosity. It has direct practical consequences. Because the magnetic field acts as a protective shield against energetic charged particles from the sun and cosmic rays, a weaker field allows these particles to penetrate closer to the Earth's surface. In the region of the SAA, this radiation zone dips down to an altitude of just 200 kilometers, intersecting the orbits of low Earth orbit satellites, including the International Space Station, ISS. When satellites and the ISS pass through the SAA, they experience increased levels of radiation, which can cause electronic glitches, temporary computer resets, and accelerated aging of onboard systems. Astronauts on the ISS also report seeing more flashes in their vision due to cosmic rays passing through their retinas when flying over this area. Consequently, the SAA is a critical factor in the planning and design of space missions. Fact 128. The North Pole has moved over 2,000 kilometers. Earth's magnetic North Pole is not fixed, it is in constant motion. Historically, this movement was relatively slow and predictable. However, since the 1990s, the pace has accelerated dramatically. Over the past century, the magnetic North Pole has moved from the Canadian Arctic towards Siberia at an average speed of about 10 to 15 kilometers per year. Since the year 2000, this speed has increased to over 50 kilometers per year. By 2021, it had officially crossed the prime meridian and is now continuing its journey eastward across the Arctic Ocean. This rapid shift is believed to be linked to changes in the flow of molten material within the Earth's outer core, specifically a high-speed jet of liquid iron flowing beneath Canada. This movement necessitates frequent updates to the World Magnetic Model, which is essential for the accuracy of all modern navigation systems, from smartphone maps and commercial shipping to military and aviation applications. Fact 129. True north and magnetic north are different. There is a crucial distinction between true north, geographic north, and magnetic north. True north is the direction pointing directly towards the geographic North Pole, the fixed northern point of the Earth's axis of rotation. It is the north shown on standard maps. Magnetic north, on the other hand, is the point on the Earth's surface where its magnetic field points vertically downwards. This is the direction a compass needle aligns with. Currently, magnetic north is located in the Arctic Ocean, hundreds of kilometers away from the geographic North Pole. The angular difference between these 2 points, as measured from any specific location, is called magnetic declination. This declination is not constant. It varies depending on where you are on the globe and changes over time as the magnetic poles wander. For precise navigation, it is essential to know the local magnetic declination to correct a compass reading and find true north accurately. Fact 130. Compasses point to magnetic north. A compass is a simple yet brilliant navigation tool that operates by aligning itself with Earth's magnetic field. Inside a compass is a small, lightweight magnetized needle that is free to rotate. Because opposite magnetic poles attract, The north-seeking pole of the compass needle, often marked in red, is attracted to and points towards the Earth's magnetic south pole, which is located near the geographic north. For simplicity, we call this direction magnetic north. It is vital to remember that a compass does not point to the geographic north pole, true north. The discrepancy between the two, known as magnetic declination, must be accounted for on maps for accurate navigation, especially over long distances. The reliability of the compass has been fundamental to human exploration for centuries, but its dependence on a dynamic and shifting magnetic field means its relationship with true north is constantly evolving. Fact 131. Earth's orbit is not a perfect circle. Earth's path around the Sun is not a perfect circle but an ellipse, a shape that is slightly oval. This means the distance between the Earth and the Sun varies throughout the year. The point in the orbit where Earth is closest to the Sun is called perihelion, which occurs around January 3rd each year, at a distance of about 147 million kilometers. The point where Earth is farthest from the Sun is called aphelion, occurring around July 4th, at a distance of about 152 million kilometers. This difference of about 5 million kilometers is relatively small, making our planet's orbit nearly circular, with a low eccentricity. It is a common misconception that this variation in distance causes the seasons. The seasons are primarily the result of Earth's axial tilt. The elliptical shape of the orbit is governed by the laws of planetary motion formulated by Johannes Kepler, which describe how all planets orbit the Sun in ellipses, with the Sun at one focus of the ellipse. Fact 132. It is a slightly elliptical orbit. The slightly elliptical, or eccentric, nature of Earth's orbit has minor but measurable effects on our planet. Because Earth moves faster in its orbit when it is closer to the Sun, as per Kepler's second law, the period from the northern hemisphere's autumn equinox to the spring equinox is about a week shorter than the period from spring to autumn. The eccentricity of Earth's orbit is not constant. It changes over a cycle of about 100,000 years due to the gravitational pull of other planets, particularly Jupiter and Saturn. This cycle is one of the key components of the Milankovitch cycles, which are long-term variations in Earth's orbit and orientation that are believed to be a primary driver of the Ice Age cycles over the past million years. When the orbit is more elliptical, the seasonal contrasts in one hemisphere can be more extreme, which can influence the growth and melting of continental ice sheets. Fact 133. We are closest to the Sun in January. It may seem counterintuitive, but Earth is closest to the Sun during the Northern Hemisphere's winter. This event, called perihelion, occurs around January 3rd. At this time, the Earth receives about 7% more solar radiation than it does at its farthest point, aphelion, in July. The reason this doesn't cause summer in the north is that the seasons are dominated by the 23.5-degree tilt of Earth's axis, not by our planet's distance from the Sun. During the Northern Hemisphere's winter, the North Pole is tilted away from the Sun, resulting in shorter days and less direct sunlight, which overwhelms the effect of the slightly closer proximity. The opposite is true for the Southern Hemisphere, which experiences its summer during perihelion. This means Southern Hemisphere summers are, on average, slightly warmer than Northern Hemisphere summers, and Southern Hemisphere winters are slightly colder than Northern Hemisphere winters, all else being equal. Fact 134. Earth is in the habitable Goldilocks zone. Earth orbits within the circumstellar habitable zone, CHZ, often nicknamed the Goldilocks zone. This is the region around a star where conditions are just right, not too hot and not too cold, for liquid water to potentially exist on a planet's surface. Liquid water is considered a fundamental prerequisite for life as we know it. If Earth were much closer to the Sun, like Venus, the intense heat would cause a runaway greenhouse effect, boiling any oceans away. If it were much farther, like Mars, the temperatures would be so cold that water would permanently freeze. Our position in this zone is a crucial factor in Earth's ability to support life. However, being in the habitable zone is not a guarantee of habitability. Other factors like a planet's atmosphere, magnetic field, and geological activity are also essential for creating and maintaining a stable, life-friendly environment over billions of years. Fact 135. The planet is just right for liquid water. The just right conditions on Earth are a delicate and complex interplay of many factors beyond simply its distance from the Sun. Its size and mass are sufficient to generate enough gravity to hold onto a substantial atmosphere, which provides pressure and insulation. The atmosphere's composition, with greenhouse gases like carbon dioxide and water vapor, traps just enough heat to maintain a global average temperature that allows for a stable water cycle of evaporation, condensation, and precipitation. The presence of a large moon stabilizes Earth's axial tilt, preventing wild climate swings. Plate tectonics act as a global thermostat, recycling carbon over geological timescales. A magnetic field protects the atmosphere from being stripped away by the solar wind. This combination of orbital location, planetary characteristics, and geological and atmospheric processes creates the uniquely stable and temperate environment that has allowed life to not only emerge but to thrive and evolve for billions of years. Fact 136. Earth is the only known life-harboring world. Despite the incredible vastness of the universe, with its billions of galaxies and trillions of planets, Earth remains the only celestial body where we have confirmed the existence of life. This makes our planet uniquely precious in all of known science. The search for extraterrestrial life is a major focus of astronomy and astrobiology, using tools like the Kepler Space Telescope to find exoplanets in habitable zones and missions like the Mars rovers to look for signs of past or present life on our neighboring world. The discovery of even simple microbial life elsewhere would be one of the most profound discoveries in human history, revolutionizing our understanding of biology and our place in the cosmos. Until such a discovery is made, Earth stands alone as a confirmed oasis of life, underscoring the immense responsibility we have to understand and protect its fragile biosphere. Fact 137. There is a layer of space junk around Earth. Encircling our planet is a growing shell of human-made debris known as space junk. This includes defunct satellites, spent rocket stages, fragments from collisions or explosions, and even tiny flecks of paint. The U.S. Space Surveillance Network is currently tracking over 30,000 objects larger than 10 centimeters in diameter, but it is estimated that there are millions of smaller, untrackable pieces. This debris orbits the Earth at tremendous speeds, around 28,000 kilometers per hour, which turns even a 1 centimeter screw into a potentially catastrophic projectile. This poses a significant and increasing threat to active satellites, the International Space Station, and future space missions. The Kessler syndrome is a theoretical scenario where the density of objects in low Earth orbit becomes so high that collisions create a cascade, each generating more debris and making certain orbital regions unusable for generations. Fact 138. Over 128 million pieces of debris orbit us. The scale of the space debris problem is staggering. The European Space Agency estimates that there are approximately 128 million pieces of debris between 1 millimeter and 1 centimeter in size currently in orbit. While these objects are small, their extreme velocity gives them the kinetic energy of a falling anvil. There are also around 900,000 pieces between 1 centimeter and 10 centimeters. This cloud of debris is concentrated in the most useful orbital regions, particularly low Earth orbit. The risk of collision is constant and requires active management. The International Space Station regularly performs debris avoidance maneuvers to shift its orbit when a tracked object comes too close. The problem is self-perpetuating. As more satellites are launched, the risk of collisions increases, which in turn creates more debris. Addressing this issue is a major international challenge, requiring efforts in debris tracking, mitigation, designing satellites to deorbit safely, and active debris removal technologies. Fact 139. The Kármán line defines the edge of space. The boundary between Earth's atmosphere and outer space is conventionally defined by the Kármán line, located at an altitude of 100 kilometers, 62 miles, above mean sea level. This is not a physical boundary where the atmosphere abruptly ends, but a theoretical one proposed by the Hungarian-American engineer and physicist Theodor von Kármán. At this altitude, the atmosphere becomes so thin that conventional aircraft can no longer function, as their wings cannot generate enough lift. Instead, a vehicle must travel at orbital velocity to generate sufficient centrifugal force to stay aloft. The Fédération Aéronautique Internationale (FAI), which maintains records for aeronautics and astronautics, uses the Kármán line as the official start of space. However, other organizations, like the US Air Force and NASA, define the boundary at 80 kilometers, leading to some debate, but the 100 kilometers mark remains the most widely recognized threshold. Fact 140. It is 100 kilometers above sea level. The 100-kilometer altitude of the Kármán line is a useful and practical benchmark, but the transition to space is gradual. At this height, the atmosphere is incredibly thin, with the pressure over a million times lower than at sea level. However, traces of the atmosphere extend much farther. The thermosphere and exosphere reach up to 10,000 kilometers, where individual atoms can escape into space. The choice of 100 kilometers is significant for human spaceflight. Those who cross this line are officially designated as astronauts. It is also a critical region for satellites in low Earth orbit, which still experience a tiny amount of atmospheric drag that gradually decays their orbit over time. This drag is a key factor in orbital planning and is also what eventually cleanses low orbits of space debris, as fragments slowly spiral down and burn up in the denser atmosphere below. Fact 141. Earth has a dust cloud satellite. Beyond the Moon, Earth is accompanied by mysterious, faint clouds of dust known as the Kordylewski clouds. These are vast, diffuse concentrations of dust particles located at the Lagrange points L4 and L5 of the Earth-Moon system. Lagrange points are positions in space where the gravitational pulls of two large bodies, like Earth and the Moon, balance the centrifugal force felt by a much smaller object, allowing it to hold a stable position relative to them. First hypothesized in the 1950s by Polish astronomer Kazimierz Kordylewski, these clouds are incredibly difficult to observe due to their extreme faintness and were only confirmed using advanced polarizing filters in 2018. They are not solid bodies but rather dynamic and constantly shifting swarms of microscopic particles, acting as temporary pseudo-satellites. Their existence demonstrates that even in the space near Earth, there are still subtle and elusive phenomena to be discovered. Fact 142. The Kordylewski clouds are quasi-satellites. The Kordylewski clouds represent a fascinating and unstable type of co-orbital configuration. They are not true moons but are considered quasi-satellites or dust clouds. They occupy the Trojan points of the Earth-Moon system, specifically the L4 and L5 points, which lead and trail the Moon in its orbit by 60 degrees. At these points, the clouds are in a delicate gravitational balance. However, this balance is easily perturbed by the gravitational influence of the Sun and other planets, particularly Venus. This means the clouds are not permanent. Their dust particles are constantly being swapped out, and the clouds themselves may dissipate and reform over time. This dynamic nature makes them more like temporary cosmic junctions for interplanetary dust rather than permanent fixtures. Studying them helps scientists understand the dynamics of celestial mechanics and the distribution of dust within our solar system. Fact 143. Earth's rotation creates the Coriolis effect. The Coriolis effect is an inertial force that deflects the path of moving objects over long distances, as viewed from a rotating frame of reference like Earth. Because the Earth rotates from west to east, a point on the equator is moving faster than a point near the poles. As a result, any object or fluid moving over the surface from the equator towards a pole is deflected eastward, as it retains the higher eastward speed of its lower latitude origin. Conversely, an object moving from the pole towards the equator is deflected westward, as it lags behind the faster moving ground at the equator. This effect is responsible for the large-scale rotation of weather systems. Cyclones spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. It also influences ocean currents. It is crucial to note that the Coriolis effect does not influence the direction of water draining in a sink, as the scale is far too small for the force to have any meaningful impact. Fact 144. It deflects winds and ocean currents. The Coriolis effect is a fundamental driver of global wind patterns and ocean circulation. In the atmosphere, air moving from high-pressure areas to low-pressure areas is deflected to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection creates the prevailing wind belts that encircle the globe, the trade winds, the westerlies, and the polar easterlies. These wind systems, in turn, exert a frictional force on the ocean surface, setting the major ocean currents, or gyres, in motion. The Coriolis effect then deflects these currents, shaping their circular paths. For example, the Gulf Stream is a powerful warm current driven by westerly winds and deflected by the Coriolis effect, which carries tropical heat towards northwestern Europe, moderating its climate significantly. This planetary-scale force is thus integral to the distribution of heat and nutrients around the globe, making it a cornerstone of our climate system. Fact 145. Ocean currents regulate global climate. The great ocean currents act as a global conveyor belt, redistributing heat from the equator toward the poles and profoundly regulating Earth's climate. Warm surface currents, like the Gulf Stream, carry tropical heat to higher latitudes, warming regions like northern Europe. Simultaneously, cold currents, such as the California current, flow from the poles toward the equator, cooling adjacent landmasses. This heat transport moderates global temperature extremes, making many regions more habitable. Fact 146. The Gulf Stream keeps Europe warm. The Gulf Stream is a powerful, warm, and swift Atlantic Ocean current that originates in the Gulf of Mexico, flows along the eastern coast of the United States, and then crosses the Atlantic towards Europe. It is a key component of the global conveyor belt of ocean circulation. As it travels northeast, it releases vast amounts of heat and moisture into the atmosphere. Prevailing westerly winds then carry this warmed air across the European continent. This is why northern European cities like London and Berlin have much milder winters than cities at similar latitudes in North America, such as Calgary or Newfoundland. Without the Gulf Stream's moderating influence, the climate of northwestern Europe would be significantly colder and more continental. Scientists are closely monitoring the Gulf Stream system, part of the AMOC, for signs of slowing due to climate change, as an influx of fresh meltwater from Greenland could disrupt its flow, with potentially severe climatic consequences for both Europe and the wider world. Fact 147. El Niño is a climate pattern. El Niño is a complex and recurring climate pattern characterized by the unusual warming of the central and eastern tropical Pacific Ocean. It is part of a larger phenomenon known as the El Niño Southern Oscillation, ENSO. During an El Niño event, the typical easterly trade winds weaken or even reverse. This allows the warm pool of water normally situated in the western Pacific to slosh back eastward toward the Americas. This redistribution of ocean heat has a domino effect on atmospheric circulation patterns across the globe. El Niño typically occurs every 2 to 7 years and can last for 9 to 12 months. It can lead to severe droughts and wildfires in Australia and Southeast Asia, heavy rainfall and flooding in parts of South America, and altered storm tracks across North America. It also suppresses Atlantic hurricane activity but can enhance hurricane formation in the Pacific. Fact 148. It can disrupt weather worldwide. The global reach of an El Niño event is a powerful example of teleconnections in Earth's climate system. The massive release of heat from the warmed Pacific Ocean into the atmosphere disrupts the jet streams, the high-altitude, fast-flowing air currents that guide weather systems. This can cause dramatic and often destructive shifts in typical weather patterns. For instance, it can lead to a persistent pineapple express pattern, funneling atmospheric moisture and causing heavy precipitation and flooding in California and the southern United States. Meanwhile, it can cause devastating droughts and crop failures in Indonesia, India, and southern Africa. The economic and human impacts are profound, affecting agriculture, water resources, and fisheries on a global scale. The strong El Niño of 1997 to 98 caused an estimated $35 to $45 billion in global damage, highlighting how an oceanic event in the tropical Pacific can ripple across the entire planet. Fact 149. La Niña is the cool phase of the cycle. La Niña is the opposite, or cool phase, of the El Niño Southern Oscillation, ENSO, cycle. During a La Niña event, the easterly trade winds strengthen, pushing more warm water westward towards Asia and Australia. This causes an even greater accumulation of warm water in the western Pacific and enhances the upwelling of cold, deep, nutrient-rich water along the coast of South America. This cooling of the central and eastern Pacific has its own distinct set of global weather impacts. La Niña often brings wetter-than-average conditions across Southeast Asia and northern Australia, increasing the risk of flooding. It typically leads to drier and warmer conditions in the southern United States and can contribute to a more active Atlantic hurricane season by reducing wind shear that would otherwise disrupt storm formation. Like El Niño, La Niña events vary in strength and duration, and the cycle between the two phases is a major source of year-to-year climate variability. Fact 150. Earth's climate has changed throughout history. Earth's climate is a dynamic system that has undergone dramatic shifts throughout its 4.5 billion-year history. The planet has experienced periods of extreme heat, like the Cretaceous period when dinosaurs roamed and there were no polar ice caps, and periods of extreme cold, known as snowball Earth events, when ice sheets may have reached the equator. These changes have been driven by natural factors operating on different timescales. Variations in Earth's orbit and tilt, Milankovitch cycles, changes in solar output, the movement of continents, plate tectonics, altering ocean currents and mountain building, and fluctuations in greenhouse gases from volcanic activity. The current period of rapid warming, however, is unequivocally driven by human activities, primarily the emission of greenhouse gases from burning fossil fuels. The rate of current change is unprecedented in the geological record, posing a unique and urgent challenge to both human societies and natural ecosystems. And with that, we reach the end of our tranquil journey through 150 facts about our incredible planet. We hope this voyage across the wonders of Earth has filled you with a sense of awe and calm. If these glimpses into the secrets of our world helped you relax and learn, please consider giving this video a like. It truly helps our channel grow. For more nightly explorations into the fascinating truths of science, history, and nature, don't forget to subscribe to the Sleepy Facts channel and ring the bell so you never miss a moment of discovery. We love hearing from you in our community. So, as you drift off tonight, tell us in the comments below, what should we explore next? The mysterious depths of the ocean? The vast, silent expanse of space? Or perhaps the incredible world of animals? Thank you for watching, and until next time, sleep well and dream curiously.